What is JavaScript? Hey folks, my name is Burke Holland, and in this video, we're going to take a look at what JavaScript is, why you should learn it, and where you can use it. JavaScript is a programming language, and this is its logo. It was originally created as the programming language that you would use to interact with elements on a web page in a browser. These are things like adding a click event to a button or changing a style with code. Now, even though it's called JavaScript, it has nothing to do with Java, but it is a C-based language, so it kind of looks like Java, but that's where the similarities between the two languages end. JavaScript is a dynamically typed language, which means that you don't need to tell it what types your variables are. It can figure that out on its own. For instance, if you told JavaScript x equals 0, JavaScript can figure out that x is a number by looking at the 0. And lastly, JavaScript is compiled just in time. And what that means is that you don't have to compile it or build it beforehand to run it. You just run it, and it works. Now, there are a lot of programming languages out there, so why learn JavaScript? Well, this guy named Jeff Atwood once said that anything that can be written in JavaScript will eventually be written in JavaScript. Now, what did he mean by that? I have no idea. But what I do know is that JavaScript is everywhere. It's in the browser, and browsers have come a long way in the last 5 years into fully fledged application development runtimes. They used to be for viewing just documents on the web. They're now for applications as well. And you can build rich, immersive application experiences in the browser that look just like desktop applications. JavaScript is on the server with something called Node.js. So anything that you can do with C# or Java on the server, you can do with JavaScript as well, like reading and writing files or interacting with the database. You can do that. And lastly, JavaScript is for native applications. Now, these are applications that you would install from an app store on your phone or on the desktop. And this is enabled by open source frameworks maintained by companies such as Facebook and even Microsoft. According to a 2019 Stack Overflow developer survey, JavaScript is the #1 most used programming language in the world. So why should you learn it? Because everyone is using it. And what do we mean by everyone? Well, all those huge websites that you love so much, your favorite social media networks and your favorite e-commerce sites, all using JavaScript. JavaScript powers the web. Huge enterprises and consumer companies that we can't mention for various legal reasons are using JavaScript and building applications that you use right now with JavaScript. And even some of the favorite tools that you're probably using right now, like VS Code or Slack, those things are written in JavaScript. In summary, JavaScript is a programming language that can be used just about anywhere to build just about anything. On the client versus JavaScript on the server. Hey folks, my name is Burke Holland, and in this video, we're going to look at the difference between JavaScript on the client and JavaScript on the server. When we say JavaScript on the client, what we're usually referring to is a web browser. Now, it could be a native application written with something like React Native or Electron, but for the most part, we mean the web browser. Now, when you're writing JavaScript for the browser, all you need is a script tag in your page, and then you can put your JavaScript inside of that script tag. But normally you don't want to put JavaScript directly in the page. You want to put it in separate files so that it's easier to maintain. To do that, you put it in a file with a .js extension, and then you use the same script tag, but you're going to specify this src attribute and point it to the script file. This is called the source attribute, and this will load the script file into the page when the page loads. JavaScript that is running in a web browser is usually being written to build some sort of a user interface. And as such, JavaScript running in a web browser has access to something called the document object model. You'll hear people refer to this as the DOM. The DOM is just the functions and objects that JavaScript has access to in the web browser. So for instance, you could use something called the document object, which is an object that just magically exists when you're running JavaScript in a web browser, and then call the getElementById method, which will return an HTML element that has that ID. And then you could do something to that element with JavaScript, like change the color. When you write server-side JavaScript, the game changes a little bit. When you're writing server-side JavaScript, you're usually not building a user interface, you're writing some sort of a web service or service in general. Then things like reading and writing files or interacting with a database, these are server-side tasks. And in order to run JavaScript on the server, you're going to need something called Node.js. Since you don't have any web browser on the server or script tags, you'll have to install this thing called Node.js on the server, and then you can execute any JavaScript file by calling node and then your script file directly from the terminal or your command line. Now again, Node.js is not a web browser. It has no visual components. So that document object model, that DOM that you have in the browser, doesn't exist in Node.js. What you get instead is something called packages. Now, some of these packages are built into Node itself. These would be things like being able to interact with the file system. And there is a repository of third-party packages called npm, which contains a package for just about anything you can think of, including one that will calculate how many pizzas you need depending on how many people you have. Isn't JavaScript spectacular? To summarize, JavaScript running in the web browser uses script tags and is primarily used for building user interfaces and interacting with the user interface elements in a page called the document object model. JavaScript running on the server requires Node.js to be installed and is usually used for things like building web services.
Hi everyone, my name is Johan and I'm a senior cloud developer advocate working at Microsoft. In this video, we'll talk about the tools that you need to set up on your machine to work with JavaScript. The first thing you'll need is a code editor to write your JavaScript code. One of the best options is Visual Studio Code. It's a lightweight code editor that can do quite a lot of things right out of the box. It supports all popular languages, that includes JavaScript of course, it has Git integration and a built-in terminal. You can also add all the features you need using extension, and we'll see more on that. The best thing is that it's completely free, works on Windows, macOS and Linux, and it's also open source. The funny thing, believe it or not, is that it's entirely written in JavaScript. And if you're curious about that, you can just take a look at the source code on GitHub. Speaking of extensions, there's a lot of useful extensions that you can find in the marketplace, and I've selected 3 of them that can be really useful if you're developing JavaScript application. Just to be clear, you don't require these to follow the next sections, but they will definitely come handy in your JavaScript journey. ESLint is a linter. That's a tool that analyzes your code to find and fix problems in it, making sure you ship quality code to production. Prettier is a code formatter. That means that you can just focus on writing your code, and this tool will take care of making it pretty and consistent all across your code base. And ES6 code snippets is for lazy developers like me. If you don't always like typing the same things, it will provide you shortcuts to make you more productive. Okay, the second thing that you will need to develop JavaScript application is Node.js. But what's Node.js? Node.js is a JavaScript runtime, meaning that you can use it to execute JavaScript code outside of the browser. Even if you plan to write web application that will run inside a browser, Node.js will provide you the environment to run all the tools you need to build your JS application, whether it will run inside or outside the browser. The JavaScript ecosystem evolves quickly, and so is Node.js. While you can install Node.js directly from the official website, you will get stuck with a fixed version. That's why it's best to use a tool that will manage your Node.js environment, including updates. For that, we'll use NVM, which stands for Node Version Manager. It's a CLI tool that you will use to install and update Node.js. If you're using macOS, Linux or WSL, you can use the original NVM tool. But if you're using Windows without WSL, you will need to install a different tool that will work roughly the same. That's it with what you need. Now let's go ahead and proceed with the installation. Hi everyone, my name is Johan and I'm a senior cloud developer advocate working at Microsoft. In this video, we'll see how to install the various tools you need to work with JavaScript on your machine. First, we'll install VS Code. Open code.visualstudio.com in your browser, download the setup file for your operating system, and follow along the instructions. If you already have another favorite editor, that's fine too. But keep in mind that you won't be able to use some nice extension that can help you greatly while developing JavaScript. Speaking of extension, once you have VS Code installed, you can switch to this pane to search and install the extension you want, just like that. Now, another important tool that you need on your machine is a working Node.js environment. To install Node.js, you can go to the official website and download the setup from there. But while that works, you may discover that's not the most convenient over time, especially when you will want to update your installation with a newer Node.js version. Another approach is to use NVM, which is short for Node Version Manager. It's a set of shell scripts that will manage your Node.js installation with an easy path to manage updates. If you type in nvm.sh in your browser, you will land on this GitHub page. Now that this one will work on macOS, Linux and WSL, but not natively on Windows. I'll show you a dedicated Windows version just after that. Now, if you go through the instruction here, at some point you can copy one of the commands here, whether you're using curl or wget, and paste it in your terminal. Wait for the installation to finish, then you'll have to copy these lines to your shell profile. If you're using bash, open or create the file .bash_profile in your home folder and paste it inside. Save the file, and now you can either restart your terminal or apply the changes using the source command. NVM should then be working, so we can use the nvm install node command to finally install Node.js. That was a bit long, but next time you'll want to update your Node.js version, that will only be one command away. If you're using Windows and do not want to use WSL, well, unfortunately, this won't work for you. But there's a similar tool that is called NVM Windows. Search for it in your browser and you'll find this GitHub page. Scroll down a bit and you will find a setup file to download. Just follow the setup instruction and you'll end up with a similar setup that I just showed. That's it, now you're ready to write some JavaScript.
First application. Hey folks, this is Burke Holland, and in this video we're going to look at creating your first JavaScript application, and specifically we're going to be making a Node.js application. Now, the first thing that we're going to need to create a project is a file, somewhere to put our code, and we can save that and we'll call it index.js, but you could call it anything you like. And we have to save it somewhere, so we're going to want to put it in a folder. Again, you can call this folder whatever you like. And just like that, technically, we have a project. Now, it doesn't do anything, but it is a project. All a project is a folder with some files or other folders that have files in it. It just contains your code. Now, let's make this project do something. One of the things that you'll use frequently in JavaScript is something called the console log command. Console log simply allows you to output a message to the console window. And the console window is a place where all sorts of messages are output, like errors and logs and any messages that you want to write out from your code. In the case of a Node.js application, the console appears in the same place where you run your code, which is from the terminal or the command line. So we can write hello world out to the console and then run this program by running node and then index.js, and we see the message written out to the terminal. Now, it's important to note that you can log out any string, including, by the way, emoji, good to know, completely valid, you can do that. Another thing to note here is that I'm using single quotes around these text that I want to write out with the console.log statement. Why am I doing that? Well, I'm doing that because I need to tell JavaScript that this is text. If I remove the quotes, then you can see we have errors. And that's because hello and world are not valid commands in JavaScript, and any text that's not inside of quotes, JavaScript thinks you're trying to call a command. And so to tell JavaScript, no, this is just text, we have to put quotes around it. Now, in my case, I'm using single quotes, but you can also use double quotes. JavaScript honestly doesn't care either way. You can use whichever one you like. Now, sometimes you want to log out the value of something that you don't know ahead of time. For instance, it could be the value of a variable or the return value of a function. The program will know the value, but you don't know the value. What you can do with console log is use something called substitutions. So perhaps we want to define a variable here, and then we want to include the value of that variable in the output message. We can write console log, and then wherever we want to have these variables or program values show up, we can use this %s. And then we just pass in the parameter, comma, after the text into the console log function. And you can have as many of these as you like, and they will appear in the order that you pass the parameters to the console log function. Now, we've seen single quotes and we've seen double quotes, but there's actually a third type of string in JavaScript, seriously, and it's called the template literal. Template literals are formed by using the backtick. Now, you can put strings inside of template literals, inside of backticks, but it also allows you to put programmatic values in your strings. And to do that, you're going to use the $ and then brackets, and then you put whatever variable you want the value of, or function or whatever, inside of that space, and that will be written into the string. Now, this is better than substitutions because it's easier to read as a programmer and see where in the string your values are when you're using template literals than it is when you're using substitutions, which can be a little bit harder to read. In summary, a JavaScript application is just a folder with some files or other folders in it that contain your code. The console.log is your best friend as a JavaScript developer because it allows you to write messages from your code out to the console. And you can use single quotes, double quotes, or you can use the backtick, which is the template literal in JavaScript, which allows you to interpolate or combine text and programmatic values, like variables. Comments. Hey everybody, my name is Burke Holland, and in this video, we're going to take a look at code comments in JavaScript. Code comments are lines in your JavaScript code that the JavaScript runtime just ignores. Now, you might want to do this for several reasons. Could be to leave a handy tip in the code that explains and gives some context. Could be to make a reminder for yourself when you're developing for something you need to come back and complete later. Or it could be to just take an active line or block of lines of code and comment them out during development so that they don't actually execute, but you're not deleting them from the file. Now, when it comes to comments in JavaScript, there are two types. There's single line comments and multi-line comments. Single line comments are indicated by 2 slashes at the beginning of a line. Now, usually the editor that you're using will gray these lines out or change their color so that you know that they're commented out. Single line comments only apply to the current line, so any code on subsequent lines still executes and is not commented out. Multi-line comments are designed to comment out multiple lines without having to put those slashes at the beginning of every line. Multi-line comments start with a slash and then a star, and they end in reverse with a star and then a slash. You can think of multi-line comments as starting with a slash and ending with a slash. And everything that's in between that is commented out no matter how many lines it takes up. Now, in the real world, most editors have a keyboard shortcut just for commenting lines out and then removing the comments. For VS Code, that's Command for Mac or Control for Windows and the L key. And this just toggles comments on and off for a line. And normally, instead of using multi-line comments, you'll just highlight a block of code and then use Command or Control L to toggle the comments on or toggle them off. And so you don't use multi-line comments as much as you think that you might in code because the editor handles the single line comments. So we don't really care how many double slashes there are since we're not manually putting them in or taking them out. Now, it's as important to talk about when you should use comments as it is about what comments are. When you first start programming, you're going to feel like you need to comment everything and say what everything does. I did this. I had comments on all of my code. That's actually unnecessary and ironically makes your code harder to read. If your code can't be understood by someone who knows JavaScript, then instead of a comment, what you might need is to refactor the code to make it simpler and easier to understand. Now, oftentimes what this means is taking a chunk of code that has a comment that explains what it does and wrapping it in a function that has a name that describes what the code does. So for instance, we might have a block of code that reverses a string and a comment that lets the reader know this code reverses a string. A better solution would be to take that code, put it in a function called reverse string, and now the code is self-documenting. We don't need a comment here. The person reading the code can look at it and discern from the function name, oh, this code reverses a string. In summary, there are two types of comments in JavaScript. There are single line comments that use 2 slashes and only apply to the current line. There are multi-line comments that start with a slash and a star and end with a star and a slash, and everything in between that is commented out no matter how many lines you use. And lastly, remember, take it easy on comments. You probably don't need as many as you think you do. Use them judiciously. See if you can make your code self-documenting instead. Hey folks, this is Burke Holland, and in this video we're going to take a look at some demos of using comments or code comments in JavaScript. So code comments in JavaScript are just lines of code that are not executed by the JavaScript runtime. So in this example here, we have a simple console log that we can run with a node index.js, and it will write out what the value of that is. Now there's two types of code comments in JavaScript. There's single line comments and multi-line comments. So to comment out this line here, I can put 2 slashes in front of it, and you'll notice that the editor changes it to a gray color. And that's how we know that the line is commented out. And if we run this again, there's no output because the runtime is now just ignoring this code. Now, why would you want to use comments? I mean, several reasons. One of them might be to just add in some context that is necessary for the reader to know about the code. So for instance, the connection string here is found in local.settings.json. Even though we don't have a connection string, maybe we pretend to have one in there. Another one might be to add a to-do for yourself. As you're coding, you might want to remind yourself and say to-do, and then come back and say add in database connection string. The nice thing about this is that in an editor, you can search for all to-dos like this with a search menu. Most editors have this, and you can find all your to-dos, and there's even some extensions in VS Code to help with that as well. And then lastly, a lot of times you just use it to comment out a line of code that you don't want to run, but you don't want to delete it either. You'll do this a lot when you're developing. Now, the other type of code comment in JavaScript is the multi-line comment. Now, multi-line comments start with a slash and then a star, and they end with a star and then a slash. And anything in between, even on the same line or the next line, all the way up until that last star slash is commented out. So for instance, if we took this here and we moved it down here to the bottom, all of this is now commented out. But this line would not be commented out. This line would still work. Now, it's important to note that in most editors, there is a baked-in functionality that allows you to quickly comment lines on and off. In Visual Studio Code, that's Command or Control and then the slash. And what that does is it just comments a line out. And if I hit it again, it uncomments it. Now, this is important to note because it also works on blocks. So if you highlight a block and then do it, the whole block is commented out. And notice that it puts the slashes on every single line. So you'll use multi-line comments less than you think you will because of this editor capability that will automatically put the slashes there and then take them off for you. So you don't really care about how many slashes are on each line because you're not the one fooling with that, the editor is. Now, it's important to talk about when you should use code comments. In this example here, we have a block of code that reverses a string. And there's a comment up top that says this code reverses a string. Now, when you first start developing, you're going to feel this pressure to explain all of your code and what it does. And you should try not to do that. Too many comments in your code makes your code harder to read, believe it or not. What you want to do instead is write code that's simple enough that any JavaScript developer could come along later and understand what it does. And remember, you're the JavaScript developer that's going to come along later, so write it for yourself. Keep yourself in mind. Now, one of the ways that you can do that, there's a lot of ways, but one of the ways is to just take blocks of code like this that need an explanation and turn them into a function. So if we take this code out, instead, we might have a block of code here where we've wrapped it in a function called reverse string. And then instead of adding a comment, the next developer that comes through here and looks at this code, which remember is probably going to be you, can see, oh, this reverses the string. And of course, this code runs as well as the other code did. We'll just run it here just to prove it. There we go. And in this way, this code is self-documenting. Doesn't need any comments. It explains what it does with the function name. So that's it. Single line comments, multi-line comments. And remember, if you can, make your code self-documenting. Use comments sparingly.
Hi, my name's Aaron Powell. I'm a Principal Cloud Advocate at Microsoft, and in this video, we're going to have a look at how we can declare variables in JavaScript. In JavaScript, there are three ways in which we can declare variables, using three different keywords: var, let, and const. And each of these will operate in a slightly different way, so it's a good idea that we understand the different ways that we can use those variables and the reason we might want to use the type of keyword to define a variable. First up, we have the var keyword. Var has been around the longest. It was the original way that we define variables in JavaScript. And var is a function scoped variable declaration. That means that the variable, when defined, is available anywhere within that function. It's even available before you might have thought you've declared it, because it's available throughout that entire function scope. This means that if you defined a variable on, say, line 10 of a function, it's actually available on line 1. The other thing with the var keyword is that the variable can be changed within the scope, meaning it's a mutable variable type. We can reassign it, we can change its data type, or anything like that we might want to do. This makes var a very flexible, but also a potentially dangerous way to declare variables. The next type of variable declaration we've got is the let keyword. Let is similar to var, except that it is block scoped instead of function scoped. This means it's only available within inside of a block, which is denoted by the open and closed curly brackets that your variable was defined in. It's also only usable after the declaration. So unlike var, where the variable is always available within inside of the scope that it's defined in, let is only available from that line down. So if you define a variable using let as a keyword on line 10, it will only be usable from line 10 onwards. Let is also a mutable variable type, which means that you can change it, its value, its type, etc., while it's inside of its block scope. But once it's outside of that scope, the variable is no longer available, so you can reuse that variable name. Finally, we have const. Const is similar to let in that it's a block scope variable, and it's only usable after its declaration. But the difference with const to let is that it can only be assigned, it cannot be reassigned. So once you've set a value to a variable that's defined as a const, meaning a constant value, you cannot change what that assignment is. So you might be wondering, when would you use one variable type compared to another? Well, the recommendation is that you use the const variable type as often as you can. It's the one you should go to first, because this helps you when you come back and look at your own code, or helps other people when they're looking at your code to understand that this variable, it doesn't get reassigned. It's only ever going to be the value that you see it being assigned to initially, and it'll be that the whole time. This is useful to ensure that you have less chances for bugs happening because a variable is being reassigned that you might not be aware of. Let is still very useful though. You would use let with inside of a loop, because this is inside of a block scope where you want to create a new variable each time that loop happens and assign it a new value. Otherwise, if it was a constant, you wouldn't be able to reuse it and reassign it for each iteration of that loop and reuse that variable name. There's no necessary reason to use var anymore because let and const can cover off pretty much all of the use cases, and they also remove some of the issues that we can have with a var-based variable declaration, particularly the fact that it's usable wherever you've got within inside of your scope and not just within inside of where you thought it was available from. Hi, my name's Aaron Powell. I'm a Principal Cloud Advocate at Microsoft, and in this video, we're going to have a look at how we can declare variables in JavaScript. In JavaScript, there are three ways in which we can declare variables, using three different keywords: var, let, and const. And each of these will operate in a slightly different way. So it's a good idea that we understand the different ways that we can use those variables and the reason we might want to use the type of keyword to define a variable. First up, we have the var keyword. Var has been around the longest. It was the original way that we defined variables in JavaScript. And var is a function scoped variable declaration. That means that the variable, when defined, is available anywhere within that function. It's even available before you might have thought you've declared it, because it's available throughout that entire function scope. This means that if you defined a variable on, say, line 10 of a function, it's actually available on line 1. The other thing with the var keyword is that the variable can be changed within the scope, meaning it's a mutable variable type. We can reassign it, we can change its data type, or anything like that we might want to do. This makes var a very flexible, but also a potentially dangerous way to declare variables. The next type of variable declaration we've got is the let keyword. Let is similar to var, except that it is block scoped instead of function scoped. This means it's only available within inside of a block, which is denoted by the open and closed curly brackets that your variable was defined in. It's also only usable after the declaration. So unlike var, where the variable is always available within inside of the scope that it's defined in, let is only available from that line down. So if you define a variable using let as a keyword on line 10, it will only be usable from line 10 onwards. Let is also a mutable variable type, which means that you can change it, its value, its type, etc., while it's inside of its block scope. But once it's outside of that scope, the variable is no longer available, so you can reuse that variable name. Finally, we have const. Const is similar to let in that it's a block scope variable, and it's only usable after its declaration. But the difference with const to let is that it can only be assigned, it cannot be reassigned. So once you've set a value to a variable that's defined as a const, meaning a constant value, you cannot change what that assignment is. So you might be wondering, when would you use one variable type compared to another? Well, the recommendation is that you use the const variable type as often as you can. It's the one you should go to first, because this helps you when you come back and look at your own code, or helps other people when they're looking at your code to understand that this variable, it doesn't get reassigned. It's only ever going to be the value that you see it being assigned to initially, and it'll be that the whole time. This is useful to ensure that you have less chances for bugs happening because a variable is being reassigned that you might not be aware of. Let is still very useful though. You would use let with inside of a loop, because this is inside of a block scope where you want to create a new variable each time that loop happens and assign it a new value. Otherwise, if it was a constant, you wouldn't be able to reuse it and reassign it for each iteration of that loop and reuse that variable name. There's no necessary reason to use var anymore because let and const can cover off pretty much all of the use cases, and they also remove some of the issues that we can have with a var-based variable declaration, particularly the fact that it's usable wherever you've got within inside of your scope and not just within inside of where you thought it was available from. Hi, my name's Aaron Powell. I'm a Principal Cloud Advocate here at Microsoft, and in today's video, we're going to have a look at a couple of demos of how we can use the different kinds of variables in JavaScript. Let's start off by declaring some variables, and we're going to use the different keywords. We'll start with the var keyword for declaring a variable. I'm just going to create a variable, we'll call it hello, and we'll assign it hello as a string. And then if we do console.log, and then provide it with the name of the variable, I hit save on that file, and then run this on our console, node demo.js, we will get, as we expect, the variable to be output, and it comes out with the string hello. Now, something we need to be aware of with the var declaration for variables is that this is a function scoped declaration, and that's important because it changes how that variable is available. Now, while it might not be clear from this file that we have a function scope here, we have a function scope inside of this file that's just implicitly put there by our Node.js runtime. So we can think of this file as one giant function that's being executed, and that's the scope in which our var variable is defined. Now with a var variable, because it's defined using a function scope, it's always available within inside of that scope. So I've just moved the declaration down to line 3 instead of line 1. And if we were to now run this from our console, we would get the output of undefined, which kind of makes sense if you understand that this is a function scoped variable, because the variable is actually defined within inside of this whole function scope, not just from the point that you've used the var keyword to declare it and forward on. So our variable is available on line 1 when we did our console.log statement. We just haven't assigned it a value, so it's implicitly undefined. Now, this is different to when we have block scope variables such as let and const. So let's have a look at let. Let is a block scoped variable that works similarly to the way that we can work with var, in that we can actually reassign it. Actually, let me just move our line down and show you what I mean by reassignment. So I've output initially with hello, and then if we'll change our hello variable to be hello world, and then we were to do our console.log statement. Oops, if I could spell console correctly. There we go. Now, if we were to execute our code again, we would see that this does output the two as we expect, hello and hello world. Now we've reassigned this variable, and we can do that with let, but let is going to be block scoped. Let's create a block, and we'll just do an if true statement. So this is just going to always be an executed if condition, because it's always going to result in true. And inside of here, we'll do let world equals hello world. And now if we do console.log of world, save our file, and then rerun, we should end up with the second hello world output, as we were expecting, because this variable has been defined and it's available for use. Let's now move that up a line. So now we're declaring it, we're attempting to use it before we have declared it. So we'll save our file, execute from the command line. This time we've received a runtime error. The reference error cannot access world before initialization. That's because we've tried to use the variable before we've initialized and declared that variable. So this is something that will happen at runtime if you try and use a let keyword to create a variable and then use that variable before you've actually defined it. Also, because this is only available within inside of the block scope, if I was to move the console.log statement to after the closing curly bracket, which is where our block ends, and execute the code again, we will get a different runtime error. Now, world is not defined. That's because it's no longer within inside of the scope. We've moved out of the scope where that variable was initially declared, the block scope, and we can't use that variable, or we can't access that declaration of that variable. This is similar to how the const keyword will work. Const works like works like let, not world. That's the name of our variable. So const, we'll create it and we'll just give it a name. We'll call it Aaron, and we'll give it my name. Now, if I was to do console.log Aaron, we would get, as we expect, the output in our console. So we'll get that variable output. Being a block scoped variable, if I was to put this inside of a block like I did with our let bound variable, then it would be only available with inside of that. So, but that's the thing that is in common between let and const. But the other thing that let has going for it that const doesn't have is the ability to change. If we were to try and change the variable, so let's try and change Aaron to Aaron Powell, so my full name, and then run our code again. Now we're going to get a different runtime error. Sorry, that's obscured a little bit. Let's just bring it up again. Run it so you can see it from behind my head. Here we go. Now we've received an error saying that the assignment to a constant variable has happened, and that's a type error. This is because we've attempted to assign a const. We can't assign a const because it's a constant. It's the value that was originally assigned to it is the value that will always be assigned to it. So now, if you want to use a variable declaration, you've got the choice between const, let, and var. Const is the one that I would recommend you use most frequently, because this helps you as the reader of your own code and other people reading your code understand that the variable you've defined should only be used once. And that's the time that you want to be using it and that you can't reassign it. A let bound variable will be useful though still inside of specific blocks that are being reused, such as a loop block, like a for loop or a while loop and things like that. In that time, you might want to use a let-bound variable instead of a const-bound variable, because you need to be able to change the value for each iteration of the loop. There's very few reasons why you would need to use the var keyword though, because as a function scope variable, its availability is increased exponentially, but also it has some challenges around when that variable is available. As we saw initially, we can accidentally use it before we've even defined the variable, which can be quite confusing when you come back and look at it later. Thanks for watching, and we'll see you next time.
I'm Jasmine Greenaway, and I'm a cloud advocate at Microsoft. Let's focus on string concatenation. Strings are the data type that represents textual elements on the web. This could be anything from the output of console.log to text on a web page. Either way, there might be a chance that you might need to format your text before it reaches its final destination, and that's where concatenation comes in. String concatenation is a process of combining two or more strings. You can combine variables that are saved as strings or actual strings, known as literals. And what you get is an entirely new string with everything that you want to add in the order that you added them. And this is all done with the plus operator. Now you might know this is also the addition operator, so you have to be a little bit careful and intentional when you're using the plus operator for strings or numbers. Let's look at our first example. String 1 and string 2 are strings because they are enclosed in double quotes. You can either use double quotes or single quotes for strings. It doesn't matter. It's really up to you and your style and your preference. And on the output in these last two console.log lines, I am joining string 1 and string 2 so that it says hello world. And then in the second example here, I'm putting the word big in between string 1 and string 2. Now you probably noticed that there's no spaces in between our strings here, but we'll fix that in the next example. In the previous example, there were no spaces in between the words. Now if we want to add spaces, we gotta do it ourselves. So in string 1, I've actually added a space after hello. So when it prints to the console on the first console.log, it has a space between those two words. And in the second example, I've added space after big so that I have space between all three words, and it looks a little nicer now. As I mentioned before, numbers and strings both utilize the plus operator, so you have to be careful and intentional with how you'd like to use it. In this first example here, I have the number 1 and the string 1, and if I use the plus operator, it's going to concatenate them to show me the string 11. And in the second example, I'm using the number 1 and the literal number 1, and I get the number 2, because I'm actually using two numbers instead of a number and a string. So just be careful when you're trying to use a plus operator with numbers and strings. It's always best to keep everything the same data type. Hi, I'm Jasmine Greenaway, and I'll be walking you through a demo on string concatenation. In this demo here, we're working with two variables, string 1 and string 2, and there are just some strings that say hello and world. In this first demo, we're using the plus operator to bring string 1 and string 2 together. Again, it's called concatenation. So when I do string 1 plus string 2, I get hello world. I can even add an additional string here, and I'm adding the word big here and saying hello big world. Now this is all great, but notice that there's no spacing in between the words. So let's fix this up in the next demo. Here we're adding some spacing to the word hello. So notice that we're using that same variable string 1, and we're just updating it so that there's some space after the word hello. So if I do the same thing I did in that previous example, I now have some space between the words hello and world. When you concatenate strings, you have to put the space in yourself. Now, what I could have also done was added a string here, like in between string 1 and string 2, and then put an empty space here in between the two. So just basically a string with nothing in it. So that's another way you can do it. And then in example 14, we've added some space after the word big. So now there's space between all three words. In this final demo, we're working with some numbers. Remember that the plus sign also works with addition. It's used for addition. So if I try to do the number 1 and the string 1, which I'm doing here with num1 and num2, and I try to print that to the console with the plus operator, I get the string 11. JavaScript just assumes that this is a string because you can't add the number 1 and the string 1 together. It doesn't try to convert it for you or anything like that. So it just assumes it's a number. And on the second example here, because we are working with two numbers, so number 1 is the actual number 1, the integer 1, and then we add the number 1 here, we add them together and it prints the number 2 because this is not a string at all. Hi, I'm Jasmine Greenaway and I'm a cloud advocate at Microsoft. Let's explore formatting strings with template literals. The syntax for template literals is a little different from what you would normally use with a string. You enclose all your text in backtick characters, and you use placeholders to insert your variables and expressions. There are many ways to format a string. So let's compare another method versus template literals. With the concatenation operator, you need single or double quotes, but with template literals, you just need that one pair of backticks. With line breaks, template literals are going to respect them, but you're going to have to add them yourself with concatenation. And finally, with concatenation, you must also concatenate any value of variable that you want to include in your text. But with template literals, you just use the placeholder to insert those values. Let's look at some examples. In this first example, I have two string variables that I want to insert into two sentences. All I have to do is reference them by name and insert them into the placeholders to complete the sentences. In this example, we're using some expressions. The first console.log is adding some numbers, but the second one is using the not operator to flip the value of the Boolean that I defined in the beginning. So all I have to do again is use placeholders to insert these values. Hi, I'm Jasmine Greenaway, and in this demo, we'll be working through some template literals. In this first example, we have two strings here in two separate variables, the words JavaScript and fun, and notice that they are strings because they're enclosed in double quotes. On line 7, here is our first template literal, and it is printing the sentence, I am writing code in JavaScript. Notice that here is the placeholder, the pair of curly braces with the $sign, and I am inserting the word JavaScript here. Also keep in mind, I know this is a template literal because it has a set of backticks here. By the way, that backtick, if you never used it before, is most likely going to be to the left of your number 1 key. So when you close all of your text in between your words, it becomes a template literal. And then you can use these placeholders. And it doesn't matter if the variable is a number or even an expression like 1 + 1, you could just go ahead and insert it in here. You don't have to worry about converting it or anything like that. So again, in line 8, we are working with another template literal, and we are now working with string 1 and string 2, and we are just inserting them here into the sentence. And here it is, printing in the console, formatting in JavaScript is fun. Also notice that template literals work with special characters right out of the box. You don't have to worry about doing any special formatting with characters like the exclamation point or period or things like that. In this example, we're working with some expressions, which you can do in template literals. So on line 14, we're adding the numbers 1 plus 1, and it prints the sentence 1 plus 1 is 2. So what happened here is that this expression gets evaluated before it gets printed to the console. And that's what's really cool about template literals. You can do things like this inside the placeholders before it gets printed or before it ends up on a web page. This other example, we're using a variable that's a Boolean and it is true. And what we do in the expression is use the not operator here to flip it to its opposite, which is false. So it evaluates this to false and it prints it to the console. And the other part here is that we just added some spacing here to space out the output on the console. So there is some space after false, and so it prints that to the console as well.
Hi, my name's Aaron Powell. I'm a Principal Cloud Advocate at Microsoft, and today we're going to be looking at data types in JavaScript. JavaScript is a weakly typed language. That means that the type system is not as rich and robust as you might find in other languages you've worked with. If you're coming from a strongly typed language like C# or Java, then the type system is going to be a lot more simplistic and a lot more flexible to what you can do. In JavaScript, our variables are defined in a pseudo-dynamic way, which means that the type that they are is determined by assignment, so we can reassign them. But that does mean that we still have to understand some of the types that we have available to us. Things like numbers, strings, booleans, dates, functions, objects, and arrays are all available in the type system. Now, we only have one number type in JavaScript, and that is actually a float value. JavaScript doesn't differentiate between whether something is an integer value or a float value. It's just a number as far as JavaScript is concerned. We also have some special types available to us that represent different things in JavaScript. Things like nan, or not a number, to detect whether something that was tried to be converted to a number is actually a valid number to start with. Null and undefined also have special use cases that we have within JavaScript, and they mean different things. Null and undefined are not the same in JavaScript. Because the type system is loose, it can be a little difficult to understand exactly what you're working with from your variables. So for that, we have two operators to help us out: type of and instance of. Type of, we provide a variable to, so we do type of and variable, or value that we've received as a function argument, and that will return us a string representation of the underlying type in the JavaScript type system. Now, this is not the same types that we saw on the previous slides, because if we were to do type of array, we would actually get object back. Now, that might be a little bit confusing, but it's because an array is actually just a special object. It has a few additional properties and a few additional functions that a normal object doesn't have, but it's actually just an object under the hoods. We would then receive something like number or string with lowercase starting letters that represent string and number types. Instance of, on the other hand, is used to be able to determine if something was created from a constructor of a particular data type. So if we had our variable, and we do variable, instance of, and our constructor type, number with a capital N, string with a capital S, etc., then that will return us a Boolean representation of whether it was created from that constructor type. Now again, this can be a little bit confusing because the constructor for number is not what we would use when we create a variable for number. Let's say we did const 1 equals the literal 1, so just the one character on your keyboard, and we did 1 instance of number with a capital N, that will return false because we didn't create it using the number constructor. It can sound a little bit confusing, but there's different use cases for the different types of operator testing, whether it's type of or instance of, to work out what the data type is. And you'll need to experiment to work out what is the way that you need to be able to test in the applications you're building. But as I mentioned before, the type system in JavaScript is loosely typed or pseudo-dynamic, which means that we can actually change that at runtime. Let's say we define a variable, well, in this case we'll call it x, and we assign it the string something. On the next line down, we're assigning it the value 1, a literal number 1 off your keyboard. And now, on the third line, we're saying 1 plus hello, and that is being reassigned to x. Now you might be wondering, well, what's the type of x, and what's the value of x? Because 1 is a number, and 1 is a string. How do we add those together? Well, what JavaScript does is it will work out that, well, you can't add those two numbers together because they're not both numbers. So instead, it will try and find a common denominator for them and it will turn them both into strings. And we would end up with the result of 1 hello as the value of x. So it's now a string type. And that's because it has been able to coerce the value of 1 into a string representation of 1 and then concat them together. You can also get caught out with equality because of the loose type system in JavaScript. In the first example, we're doing x equals 0 double equals an empty string. Now this will, again, not be an easy thing to be able to do an assertion against because, well, 1 is a number and 1's a string. But what's happened is that JavaScript is going to coerce them to the same type. Both these values are falsy values. 0 is a falsy value in a number, and an empty string is a falsy string value. So it will coerce them into both being a Boolean type. And then false equals false, and that becomes true. So that's why x would be true in the first case. So it doesn't care about the original types, it will just try and attempt to make them the same types if you use a double equals operator. Instead, we should probably use the triple equals operator. This does a type safe comparison between two values. It will no longer coerce them into being the same type. So it will say, is the number 0 equal to an empty string? Well, no, because they're not the same underlying type, and immediately x will be assigned the value of false. So that's, again, something to be careful of inside of JavaScript because of the loose type system. So it's always recommended that you use the triple equals operator to do type testing. Hi, my name's Aaron. I'm a Principal Cloud Advocate here at Microsoft. And today we're going to be having a look at a couple of demos of how we can use the different data types with inside of JavaScript. We're going to start off by creating a couple of variables. We'll create one which is an array. We'll call this people, and we'll give it an array of people names. And let's create some primitive types as well, such as numbers and strings. So we'll do const 1, assign that to literal, and we'll create a string. We'll create a Boolean, and we'll create a variable. We'll create an object variable, person, and this can have a first name property and a last name property. And finally, let's create a function. Create a function, say hello, and it'll take the person, and we'll console.log hello, and we'll just do person.first name. We're not actually going to execute this function. I'm just using it so that we can have a look at the different data types. Now let's just put out some logging information and use the different operators we can to test types. So we're going to start with the type of operator. So just output, say type of, so that we know that this is the type of operator, and we'll do console.log type of people. And let's just duplicate this line a few times, and we'll do 1 string Boolean person, and then one more, and that's say hello. We'll come over to our console and we'll run that. So node demo.js, and we'll see in our output of type of, we've received object, number, string, Boolean, object, and function. Most of those look correct, except for one, the first one. The first one returned type of object, but we provided with people, which is an array. Now this is something you've got to be careful with the type of operator, because type of will test against the primitive type within inside of the JavaScript type system. Now an array in JavaScript is actually just an object with a couple of extra methods and properties on it that make it behave like an array. Now that can trip you up if you're doing type of testing to work out what the variable is. Everything else is correct, but we're not so correct on the array. Another way we can test is using the instance of operator. So let's just output what the instance of operator will provide us here. Instance of, and then we'll do console.log, and this time we provide it with the variable name, so people, instance of, and then the constructor we want to test it against, array. Oops, and I've spelled instance of incorrectly, instance of. Now we'll duplicate this a few more lines and update this with all of our other variables. Be person, and say hello. And I just realized I put my name instead of array. So there we go. There we go. It's not an instance of me, it's an instance of an array. And then number, string, Boolean, there we go. Object, and lastly, function. Okay, now let's execute the output there, node demo.js. And we'll see that we've received true, false, 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 true, true. So we've got correct this time with our array. It knows that the people is an instance of an array, but number, string, and Boolean for our number, string, and Boolean variables have not returned true. They've returned false. We got it correct again with object and function. Now, the reason for that is that when we're doing an instance of test, it compares against the instance constructor that is used to create the variable. In this case, whether it's an object constructor, an array constructor, a number constructor, etc. When we created our number, string, and Boolean variables, so on lines 2, 3, and 4, we used literal values, not constructors. Instead, if I was to do new number and provide it with a value, this time, if we were to output, let's just pop that up and then we'll do node demo so it doesn't hide behind my head. We'll see that this time we have the correct output for instance of, so the second one is true because it is an instance of the number constructor. But if we have a look at the type of test, we received object because the type of it is an object because it was created using a constructor, not using a literal. So this is where you've got to be careful around using the different type of an instance of tests against the variables and values you're being provided to work out what data type they actually are. It's always good to test a couple of different ways depending on what are the needs of that bit of code. Thanks for joining me. I hope to see you next time.
Hi, I'm Jasmine Greenaway and I'm a cloud advocate at Microsoft. Let's do some math with JavaScript. This example shows basic arithmetic: addition, subtraction, multiplication, and division. With division, the number on the left is divided by the number on the right. Here's some more operators. The first one is the remainder. It's also called the modulo operator. And the last two are shorthand ways to increase or decrease a number by 1. If you need to do more than basic arithmetic, use the math object. It comes with a set of constants and functions for more advanced mathematical operations. This short example returns the constant pi and gets the square root of the number 100. Hi, I'm Jasmine Greenaway, and in this demo, we'll be doing some arithmetic. Line 1 is just a variable that we'll be using throughout this demo. It's the integer 100. So in this first example, we are doing some basic math: addition, subtraction, multiplication, and division. One thing to keep in mind with division is that the number on the left is divided by the number on the right. So the output here is 125 for addition, 0 for subtraction, 10,000 for multiplication, and then we have a fractioned number or a floating point number that represents the number 100 being divided by 1500. Moving along, we're doing some additional mathematical operations. The first one here is grabbing the remainder. So as we saw in the previous example, that 1500 does not go into 100 at all. So there's going to be a remainder, and that remainder here is 100. And then in the second example, we are looking at the increment operation. And then on 14, we're looking at the decrement operation. And all these are doing is either increasing num1 by 1 or decreasing it by 1. In this final demo, we're using the math object, and the math object is built in the JavaScript. All you have to do is write the word math, dot, and then whatever you'd like after it. So here I am getting the number pi. This is being printed out down here. And then I am getting the square root of number 1, which again is a number 100, and the square root of 100 is 10. I'm Jasmine Greenaway, and I'm a cloud advocate at Microsoft. Converting values from one data type to another is a common practice amongst many programming languages. Let's explore how to do this with numbers and strings in JavaScript. If you want to convert a string to a number, use either parseInt or parseFloat. The difference between the two is that parseFloat works with decimal points, also known as floating point numbers. If you try to use non-numerical characters in a string with parseInt or parseFloat, it might have unintended results, so just be careful. If you'd like to convert a number to a string, use the toString method. This example is converting some numerical strings to numbers. Except for the third example, notice that we're trying to convert a non-numerical string to a number, but that returns not a number. But on the fourth example, we have a non-numerical string, but JavaScript assumes that this is a hexadecimal number, so that's why it returns 15. This example is using parseFloat to convert some numerical strings that also have decimal points to numbers. Notice that just like parseInt, you can't try to convert a non-numerical string. It'll just return not a number. These first two conversion examples shows what happens if you try to use parseInt with special characters. Anything after a special character gets ignored. The last example is a special case using template literals, which is a string, but we can evaluate the expression 1 plus 1 before we convert it with parseInt, and that returns 2. In this final example, we're converting some integers and some floats to string. And in this demo, we're going to do some conversions with strings and numbers. Throughout this demo, we're going to be using two variables, num1, which is the number 150 as a string, and flow1, which is a floating point number, and it's 1.50 and also a string. In this example, where we're converting strings to integers, we're using the parseInt function. This is built in to JavaScript, so you don't have to add a library or anything like that. You just use it in the casing that you see here, so lowercase p, uppercase I. So here we're converting the string number 100, then we convert num1 to the number representation of 150, and notice that we try to convert the string ABC, but it's not a number, so JavaScript prints not a number to the console as well. Line 9 is a special case because 0xf does have non-numerical characters in it, but JavaScript treats it like a hexadecimal number. So it prints the number 15, and that is the integer form of this hexadecimal number here. On lines 13 to 15, we're converting some strings to floats. Notice that the casing is very similar to parseInt. So in this first example, we're converting the number 1.00 to a floating point number, and it just prints 1. It drops the zeros after this, and there are ways to format this if you would prefer to preserve these zeros after this 1. In line 14, we are using the variable 1.5 that was a string to convert it to the floating point number 1.5. And again, on line 15, we are trying to convert a string that is not numerical to a number, and it prints not a number. On line 20 and 21, we're just doing some more examples here. Notice that parseInt is trying to convert 1.5. What happens here is that parseInt will ignore any characters and then ignore any numbers that have to be after any special characters. So the only characters that are allowed in parseInt are numbers, or numbers that represent either hexadecimal or octal or things like that. So here it just prints 1. Now say this was 0.5, it would actually print not a number, because the first thing it reads is that period character, and that's not a number. On line 21, we're doing a similar example. here we have 1 plus 1, and you would expect that maybe you would print 2, but remember this 1 plus 1 here is a string. So what it's going to do is it's going to look for any numbers as the first character. What's happening here is that parse int sees the one character here and it converts that to 1, notices that there's a space, and then notices that there's a plus sign after here, which can't be parsed to numbers. So it just ignores everything after the plus sign and actually everything after the space, and then just prints the number 1. Now line 24 is a pretty special case here where it uses temperate literals. And a temperate literal is a string, and the cool thing about it is that you can evaluate expressions inside the temperate literal before you do anything else with it. So here we're evaluating the expression 1 plus 1 with these placeholder characters here, the $sign and the curly braces. And then we evaluate that to 2, and then we convert it with parse int. So at this point, it is a string representation of the number 2, and then parse int goes and finishes the work of converting it to 2. And that's why it works here. And in this final example, we're converting some numbers to string. And this is pretty straightforward. No matter what number it is, you're just going to use the method toString to convert it to a string. And notice that, again, it is case sensitive, and also keep in mind to add the open and close parentheses here as well. Hi, I'm Jasmine Greenaway, and I'm a cloud advocate at Microsoft. In software development, it's important to consider and be prepared for when things go wrong. We can do this in our code. So let's explore how to handle errors in JavaScript. Exceptions are interruptions in the intended execution of code. And this is typically caused by errors. And errors are when things go wrong in our code. For example, if you write incorrect syntax in JavaScript, sometimes your code won't execute at all. You can think of errors as what went wrong in your code, and exceptions as where and when it went wrong. When something goes wrong in your code, you'd like to know why. So when an exception is thrown, it carries a message telling you what went wrong in your code. Exceptions can be thrown by JavaScript or manually by the developer. This example shows 2 exceptions being thrown manually. When you throw an exception, you can send some additional information along with it. This can be anything from a primitive data type all the way to a complex object. It's really up to you. This exception is throwing a string and a Boolean. Uncaught exceptions can be critical, dangerous, or confusing interruptions. So it's important that we tell our code what to do next when these situations arise. And we do this with try, catch, and finally. Try monitors the lines of code that might potentially throw an exception, while catch will handle what happens when an exception is thrown. And finally, will optionally control the flow of code even when an exception is not thrown. In this example, we're using only try and catch. In this first example, imagine we have some critical code in a function called critical code. This is code that could potentially throw an exception. If that happens, we'll catch the exception in the catch block. First, it'll log an error to the console, then it'll call a function to log the specific exception that happened so that we can look at it later. In this example, we're throwing the exception ourselves. So when it gets caught in the catch block, it'll print to the console and it'll log the error for us to read later. In this try, catch, and finally example, the code that's in the finally block will run every time, whether or not an exception is thrown. Hi, my name is Jasmine Greenaway, and in this demo, we're going to be working through some error handling. In this demo, we're working with two functions. This first one is critical code that throws an exception for us that we'll see throughout the demo. And then we are also using another one that we'll see called log error, and that will just print the exception to the console. In this first example, we are throwing two exceptions. The first one is a string, and the next one is Boolean. And notice that my syntax highlighter actually faded out line 13, because remember that exceptions and thrown exceptions are an interruption in your code. So that essentially means that code that might show up after an exception is thrown might not get run. And that's what my syntax highlighter is trying to tell me, and that's what my editor is trying to warn me about. When it's printed to the console, you can see that the exception that was thrown shows up, and then also the message that that exception carries, which is just my string. Now, if I were to throw that true example here, the one where I threw a Boolean on line 13, the one that is unreachable, it would just say throw true, and it would say true at the end here. Let's look at try catch. So here we're calling the function critical code. And remember, that was the function we saw earlier that is throwing an exception. So that means that code inside of the catch block here will definitely run. So here we write something to the console that says got an error, which you see here. And then we log the error, and we're just logging the exception that is in the critical code. So let's just scroll up here just to see what that looks like. So here, critical code, the exception was throwing an exception. So log error logs the exception. That's why it says throwing an exception down here. So let's move along to throwing in try catch. So this is very similar to what we did with that critical code function, except we're just throwing the exception right here into try. Normally, you wouldn't want to throw an exception just like this. This would probably be in something like a if statement. For example, if you try to do something like a get request and maybe you didn't receive the data that you were expecting, you might want to throw an exception. So in this example, we're throwing this exception, and again, we're writing to the console that we got an error, and then we log that error to the console. And so it says an exception that's thrown every time. So in this try catch final example, we again use that critical code function that we know will throw an exception. So that means that code inside this catch block will run, so it'll log this message that says got an error, and it'll also log the exception that's inside critical code. And then we move on to finally. The code inside the finally block will be run every time, no matter what. So even if critical code did not throw an exception, the code inside finally will run, and that's why it prints code that will always run here.
Hi there, I'm Christopher Harrison, Senior Program Manager, Microsoft Cloud and AI. Let's take a look at how dates work inside of JavaScript. Now, I don't need to or mean to necessarily get like all deep and philosophical, but time is just a construct. Or at the very least, in JavaScript terms, time is an object. So let's take a look at this object and see how we can utilize it to manipulate time. Well, at least in our code, not necessarily in the real world. Yet. All right, so all of my bad jokes aside, working with dates and times in JavaScript centers around one object, and that is the date object. This date object is going to actually contain both the date and the time. Now, one thing that I want to highlight here is the fact that internally, time is actually stored as the number of milliseconds since January 1st in 1970. And this will actually become a little bit of a thing later on, but I just always like to call that out right up front. Now, to create a brand new date object, we simply say const now equals new date. And that will give us the date and time for right now. Well, what happens if I need to program something where I'm going to be working with a particular date and I need to make sure that I'm able to go ahead and set that? Well, there's actually a few different constructors that are available to us with date. One of them will give us the ability to specify the year, the month, the day. So this would be 2015, the 12th day, and then actually the 4th month. Now, one big thing to keep in mind about the way that months are specified on the object is they start with 0. So 0 would be January, 1 would be February, 2 March, and then 3 would actually be April. So this would be April 12th, 2015, and then the time would be 6 a.m., 24-hour clock, 25 minutes, and 58 seconds. If all we want to do is specify the year, the month, and the day, then we can do that. And this would be 1995, August, because again, remember, starts with 0, and then the 24th. Now, one thing to keep in mind is that when we print out the days by default, and you could always go in and specify different formatting and so forth, but by default, it's going to emit it using a standardized output. And you are going to notice that it will specify April and August more traditionally there. So internally, it's doing it as 0. But when it goes to display it out as part of a string, it is going to display it quote unquote correctly, or at least the way that we as humans would expect it. While I might personally want all counting to start with 0, I'm probably relatively unique in that aspect. As far as setting all the individual values go, you're going to notice that there's a whole set of different set methods that you can use for the year, the month, the date, the hours, the minutes, and the seconds. Now, the 3 that I want to call out here real quick. First is month. Again, remember, counting is going to start at 0. The date, that's actually going to set the day. And then again, that hours is going to be the 24-hour clock. So by the time that we're all done here and running this code, it's now going to be April 4th of 2014 at 4 in the morning, and then 24:46. Now you might notice the display there of 11, and the reason for that is because it's doing an offset of UTC on the display. So that's why it's showing us 11 down below there. But at least for my time, which is currently Pacific time, it would wind up being 4 in the morning there. To get our values, you're going to notice that just like all the set, we have a whole bunch of gets as well. So get month will get us the month. Get day will get us the day, Sunday, Monday, Tuesday, where Sunday starts as 0. And then last but not least is get time. Now, one big thing to keep in mind about get time is the fact that it's going to give us back the number of milliseconds since January 1st of 1970. So that could be the potential output if we added in just a little bit of string formatting. And speaking of adding in string formatting and actually running our code and doing all of that, let's go do it. Let's take a look at how we can work with dates inside of JavaScript. Christopher Harrison, Senior Program Manager, Microsoft Cloud and AI. Let's see how we can work with dates through a demo inside of JavaScript. So here is my little IDE. Of course, it's empty. And what I'm going to do is I'm going to say const now equals new date, just like that. And then let's just go ahead and do a console log and then now to go ahead and print that out. So if I go ahead and I say node my dates.js, what you're going to notice is it's going to give us this standardized time where it's going to tell us the year, month, and day. And then it's going to give us the time here, and it's going to be offset from UTC. So that's why it currently says 2300 here. It's actually 4 o'clock. So if you do some real quick math, I'm in the Pacific time zone. That would lead you to that 2300 there. Now, one thing that's worth noting is the fact that we can always go in and manipulate the date or, specify a date that we might want. So I could say something like const win 95 launch equals new date. And then it's going to show us that we've got, a few different overloads that we can take advantage of here. So I'm going to specify the day as 1995. I'm going to specify the month as August. And remember that that's going to be 7. And then I'm going to specify the day as 24. And then let's go ahead and print that out. Win 95 launch, just like that. And now let's just go ahead and run this. And now what you're going to notice is that it gives me that 1995 8, because again, August, our counting on months is going to start with 0, and then 24, just like that. It's going to set the time to midnight. Again, remember the fact that it's always going to be based off of UTC. Now, I am presently UTC minus 7 here. So that's why it's showing you that 7 a.m. It's actually going to be midnight. Now, if you want to play around with the date. So let's say const demo date, very creative with my names, equals new date. I can demo date dot and then start setting really any individual component that I might want on this. So I can set the date, I can set the hours, I can set the month, whatever it is that I might want. So if I want to maybe change the month to be January, so again, that's going to be 0. And then I go ahead and say console.log my demo date. And now let's go ahead and just rerun that. Cool, and it's going to be this first one here. Now what you're going to notice right there, that 0, 1, that is going to be the month that I set it to. Now, it's also worth highlighting the fact that we can go get individual, let me just move all of this down here. There we go. That we can always get individual components as well. So I could maybe do something like this where I say console.log, such a wonderful toy, and then I can say maybe day of week, and then like this, use the cool little string formatting that's available, and then I could say my demo date.get day, let's say. And what this is going to give us is starting with 0, it's going to give us the day of the week. So 0 would be Sunday, 1 would be Monday, and then the 2 here would indicate Tuesday. And so whatever component it is that you might want, so maybe I could say the date. So this would actually be the calendar date. I could go in and say get date, just like that. Save, rerun that, and now what you're going to notice is that date of 21. Cool. And now, granted, there obviously is a lot more available to you when it comes to working with dates inside of JavaScript. The goal here was to show off some of like the more kind of common core things that you might want to work with a date. But if you check out the supporting materials, check out the docs, you're going to notice there's a lot more that you can play around with when it comes to dates inside of JavaScript. So hopefully that gave you the core, and then from here you can continue to build. I'm Christopher Harrison. I'm a senior program manager inside of Microsoft Cloud and AI. And in this section, I want to take a look at how we can write if statements and some Boolean logic inside of JavaScript. So let's get right on into it. So when it comes to comparing values or Boolean logic inside of JavaScript, what you're going to notice is that the operators for less than, greater than, less than equal, greater than equal are pretty consistent with all programming languages. That you can see them all right there, and there's really no surprises. But what you're going to notice, though, is that I've left equals off. And the reason that I did that is because equals behaves a little bit differently inside of JavaScript. Now, one big thing to know about JavaScript is the fact that it will try to help you out as the developer by automatically doing data type conversions. And while this might be something that you're looking for, it's very infrequent. Typically, this is not the behavior that we expect. And so as a result, this can actually lead to bugs in code. So JavaScript gives us two different comparison operators. We've got the double equals and we've got the triple equals. Now, in the case of the double equals, what's going to happen is it will automatically do a conversion there. So as a result, the string of 42 would actually be equal to the number of 42. Probably not what we were expecting. But if we use the triple equals, now those two values are not going to be equal because one is a string and the other one is a number. This is typically the behavior that we're expecting. And so as a general best practice, you should always use the triple equals. That's going to be giving you what you expect when you do your comparisons. Now, as you also might expect, our not equal operator, we just simply put in a bang or exclamation point in front of the equals. And again, that's going to be a regardless of data type. And then the bang two equals is going to check for that as well as the data types. So there's our not equal operators. And again, just like before, our best practice is always use the bang and then the double equals after, because that's really actually going to be all three. So that will be checking for both the values and the data types there. Again, that's typically what we want. When it comes to the if statement logic, the way that we build up an if statement is we say if whatever our condition is inside of parentheses, and then what we want to have happen on the true side inside of that curly braces. So in our case, with our status being 200, it's going to print out console.log, or it's going to run the code console.log, and OK. So the printout would be OK in this case. Now, if it turned out that it was a value other than 200, then it's going to start stepping down from there. So it would look at the next else if, the next else if, the next else if, until it eventually runs out of items and gets to that else. That else at the very bottom winds up becoming a catch-all there. So if it's not 200 or not 400, then it would print out that unknown status down at the very bottom. It's worth highlighting here that in JavaScript, similar to other languages like Java, C#, TypeScript, if what you're doing is a single line of code, then you can actually skip the curly braces. So I could actually, in that case, just simply write if status equals 200, console.log OK, do my else if right below it, and do my else right below that. And that actually gives me the exact same logic as this right here, just in slightly less space. Now, some developers like this. I personally don't use this because it can actually lead to some potential errors later on. So I typically don't use it. I know some developers like it, and that's why it's there. So that way you can see other options. The last one that I want to take a look at is what's known as the ternary or potentially instant or inline if statement. And so what this would do is it's actually going to do our check right here in the middle. You'll see that status equals 200. This is going to be the check. And if it turns out that it's true, then it's going to give us back the OK. And if it turns out that it's false, then it would wind up giving us back the error. And that value would then wind up inside of message. This is definitely one of those where it's better if we see it. So let's get in, write some code, and take a look at all of this in action. There, I'm Christopher Harrison, Senior Program Manager inside of Microsoft Cloud and AI. And this time I want to take a look at syntax for if statements inside of JavaScript. So I've got an empty little file here. Let's start filling it up with a bit of code. So I'm going to start off by saying const status equals 200. And let's start coming up with our different display messages here. So I'm going to say if status equals 200, and then we'd have the true side here. And in our case, I'm going to print out OK, which I'll get to in a second. But I'm Christopher Harrison, Senior Program Manager inside of Microsoft Cloud and AI. And I want to keep on keeping on talking about Boolean logic and other options like switch that are available to us inside of JavaScript. So let's start off by talking a little bit about implicit conversions to Booleans inside of JavaScript. Now, this is something that a lot of programming languages do, including, say, like Python, where it will look at a variable, and if it's storing the default value for that data type, so an empty string in case of a string, a null value in case of an object, or 0 in the case of a number, all of those will automatically test as false. And so this can be a really quick way for us to check to see whether or not a variable is storing a value. So with that logic there, it would not print out x contains a value because x is 0. Now, just like with our equality operator, we can also still use the exclamation point or bang to reverse that. So if I take that logic and I put a bang in front of the x, now what's going to happen is I'm looking to see whether or not this does not contain a value, because it's going to convert that x into a Boolean, so it would be false, and then it's going to reverse that into true. And so now in this case, it's looking to see whether it's looking to see that it contains no value, and that's what it's going to display. And just like I sort of tripped over my words there, it's a good reminder that when you're writing your code, you typically want to look for the positive rather than looking at the negative. Finally, strings in JavaScript, when we're doing our comparison, are going to be case sensitive. So in this particular case, where I've got my name equals Christopher, lowercase c, and then I'm going to do my comparison with a capital C, those two strings are not going to be equal. You could handle this by either converting them to all upper or all lowercase, or you could also take a look at something like locale compare, which you can look inside of the supporting documentation for a little bit more information on that. Also, just like other programming languages, we can combine comparisons by using the AND operator, which is the ampersand, or the OR operator, which is the pipe. Now, keep in mind that with AND, both sides need to be true in order for that to evaluate as true. And with OR, only one side need be true in order for that to evaluate as true. Now, one thing that you might have noticed is the fact that we've got a single and a double of each one of those. You might be wondering, what's the difference? Well, the double is going to be known as a shortcut operator. And what that will do is it will actually skip the second side if it turns out that the first side gave it the answer. In the case of an ampersand, which is our and, what's going to happen is if the first value is false, it's going to skip evaluating the second. Why? Because if that first one is false, the entire thing is guaranteed to be false. They have to both be true in order for it to be true. If one's false, we've already failed it. And the same is going to hold true with our or statement. Of course, the difference is the fact that if the first one is true, now we know it's going to test as true, and so it will wind up skipping that one. As a general rule, you want to use that amper and pipe pretty much always, because it's always going to be what you want. I've only run into a couple of cases where what I wanted was the single one. Now, if we take a look at how we can combine these, you're going to notice on our else if that I've got my or. So if the status is 400 or 500, then we're going to print out error. Now, you might be looking at that and you might be going, wow, there could be a lot of different values here that I want to go in and test for and do different things on, and I could wind up with a really long statement here. Well, this is where switch, or as some people like to call it, a case statement, or maybe even just switch case, comes into play. That with a switch statement, what we'll do up at the very top is indicate this is the value that we're going to test. So we're going to test our status. And we're going to look to check for all the possible cases, all the possible values. So could it be 200? Could it be 400? Could it be 500? Now, the couple of things that I want you to notice here. Number one is the fact that it's always going to check for equality. So I'm not able to do less than or greater than here. Now, fortunately, one thing that I can do is stack one after the other. So that second block that you're seeing there of that case 400, case 500, that's basically like an or. So if it's 400, it would run the code, and if it's 500, it would run the code. Now, one big thing to keep in mind about writing switch statements is that that break statement is required. If you don't have that break statement, what's going to happen is it will perform what's known as a silent fall through, meaning that it will keep running all of the logic that it sees. So without that break statement, what would wind up being printed out on the screen would be okay, error, and if we didn't have that second break statement, it would even print out unknown value, silent fall throughs. Typically not what you're going to be looking for when you're writing your switch statements. Let's get in and take a look at the syntax here and hopefully bring all of this together for you so you can see how our Boolean operators, our various bits of logic work inside of JavaScript. Hi there, I'm Christopher Harrison, Senior Program Manager, Microsoft Cloud and AI. Let's take a look at the syntax for some of the other Boolean options and switch statements inside of JavaScript. So again, I've got an empty code editor here. Let's start filling it up with some code. Let's take a look at how we could do, first of all, implicit statements, or implicit false is what I'm going to call this file. Okay, cool. So now I'm going to say const, and let's say name equals, and let's use an empty string. And I'm going to go ahead and say if name, then console.log, we have a name. And let's, for right now, put in an else statement. And I'll say else console.log and no name provided. Cool. So now I'm going to save this. I'm going to go ahead and run this. We'll say node implicit false, hit enter, and you're going to notice that it gives us no name provided because that empty string automatically converted into a false. Now again, I could go ahead and use a Boolean to reverse that. So if I put in a Boolean here and I change my logic around like that, you'll notice that we're going to get the same result, that it's going to tell me, again, no name provided. And the reason for that is because this is now going to become, in our case, true, because it will convert that name to a false, change that back around to a true, and then go ahead and run it. Obviously, that's a little convoluted. And it's also a big part of the reason why I try to avoid using that that type of syntax and try to just avoid the negative whenever possible, just because it can lead to kind of more convoluted code. And I always like my code to be nice and readable, you know? So I personally always try to aim for the positive whenever possible. I do want to highlight our case sensitive.js. So I'm going to say const name equals Christopher. And let's go ahead and say if name, actually, you know what I'm going to do? I'm going to do this instead. I'm going to say, I'll say status. There we go. That's going to work a little bit better. I'll say status. And I'm going to say if status equals error, then we'll go ahead and print out console log something went wrong. Otherwise, console.log looks great. Cool. Okay. So now if I go ahead and run this, I'm going to say node, casesensitive.js, what's going to happen is it will come back and say, looks great, which is not what we were expecting. Well, we should have been expecting this. And the reason for that is, again, our string comparisons are going to be case sensitive. So one way that you could handle this is by doing a to uppercase. In my case, see what I did there? So now it's going to convert to uppercase, and now it will give us an error message. So now when I run this, it tells us something went wrong, which is what we were expecting. Now, that's one way that you can do it. I do again want to highlight that locale compare. You can go check the supporting docs for a bit more information on that. Now, I want to close this out by taking a look at using and statements here, and also using switch. So first of all, let's say and.js, and I'll say const status equals 200, and I'll say if status equals 200, console log OK, and else if status equals 400, or, there it is on my keyboard, status equals 500, then we'll go ahead and console.log error. And now our else statement down there at the very bottom, and I'll go ahead and say console.log and unknown status. Cool. All right. And now if I go ahead and I run this, this would give me an OK. Let me have it display an error. I'm going to say 500. So let me clear down below node, and I'm going to say and.js. And when I run this, it's going to display out error because, again, it's set to 500. OK. Now, as highlighted in the slide, I could also do this by using a switch statement. So I'm again going to do a nice little side-by-side comparison here so we can see the same logic. So I'm going to say const status equals 500, and I'm going to say switch, and I'll put status in there. So this is going to switch, if you will, or check the status. And if it's 200, then we'll go ahead and say console log OK. If it's, and I know I'm doing something wrong here and I'm doing it on purpose, So I'm going to say case 400, and I'll say case 500. This is an OR here, so either one of those match. It'll say console.log and error. And then finally, our default, this is basically our else statement, if we will. We're going to say console.log, and we'll say unknown status. And something really funny is going to happen. That when I run this node switch.js, it's going to print out both error and unknown status. And the reason for that is that silent fall through that we were talking about previously. That if we don't stop it, it's just going to keep going to the next one and to the next one and to the next one. So we want to make sure that we're always putting in a break statement here. And I'm just going to copy and paste to make my life a little bit easier here. That without it, it's just going to fall through everything. And if my status was 200, it would have printed out OK, error, and unknown status, which again, not what we're looking for. So I'm going to leave that with our breaks now. Now we'll go ahead and run that. Now we get error. It's doing just that one in the middle, which is exactly what we were looking for. Yes, we were looking for an error. And so that is a couple of the other options available to you when it comes to Boolean logic and JavaScript, and how we can use a switch statement and how it compares to writing out an if statement. One last little thing I want to highlight before we close it all out is remember again that with a switch statement, and this is a big difference here, why you might decide to use an if as opposed to a switch, is a switch statement can only check for equality. It's only checking for equals. You're not able to do a less than or greater than directly inside of a switch. And so there it all is.
Hi, I'm Jasmine Greenaway, and I'm a cloud advocate at Microsoft. Let's create our first array. An array is a list or collection of values. And one of the benefits of an array is that you can save many different values of different data types. When a value is added to an array, it gets assigned a special number called an index. This is a unique number that can be used to reference and access that value in the array at any time. Arrays also come with a special property to get the length of the array at any point. This example shows two ways to create an array. The first example creates one with a set of square brackets, while the second example uses the array object. The only difference here is that you have to set the length of the array if you want to create it with the array object. This example creates two arrays and gets its length. Array 1 has a length of 0 because it's an empty array, but array 2 had its length defined when it was created, so that's why it's 5. Hi, I'm Jasmine Greenaway, and in this demo we're going to walk through creating arrays. In this example here, we're looking at two ways to create an array. This first one is array 1, which is just a set of square brackets. So you just have a set of open and closed brackets to create an array. The second one uses the array object to create an array. So you would just write the word array with the capital A to preserve the casing, because this is built in JavaScript. And in the parentheses here is where you have to specify the length. This is a required number. So you could either put this in a variable and then add it into this parentheses here, or you could just put the number, I could have just put the number 5 in here as well. So now I have two arrays, one that has a length of 0 because I haven't specified its length for array 1, and an array with a length of 5. So if I move on to this next example, I will see here on line 11 and 12 that 0 gets printed to the console because array 1 has no length. We just created an empty array. And on line 12, we see that array 2 has a length of 5 because remember we used the array object to create that second array. And remember that we have to specify the length here. Hi, I'm Jasmine Greenaway, and in this demo, we're going to be walking through working with data in arrays. In this first demo, we are adding data to an array while it's being created. On line 3, array 1 gets populated with the string A, the Boolean true, and the number 2. And then we print it to the console. So we print the value at index 0, which is A, and the value at 1, which is true. Moving along, array 2 is a new array that we've created, and we're using the array object to create it. And with that, we have to set the length as well, and we've set that as 2. Then we insert values into the array. So we are adding data to this array after it's already been created. And you can do this at any time once the array has been created. So here on line 11, we are inserting a string at index 0. And the string is a sentence that just says value at index 0. On line 2, we print the value at index 0, which is the string that we just inserted. But notice that line 13 actually prints undefined because we haven't inserted a value there yet. That just means space has been saved, but we just haven't added a value there yet. In this last example, we're doing another experiment with length and index. And here we're using the array object to create an array with a length of 3. We just inserted the number 3 in here. And we add a value at the last index of the array, which is index 2. And here we're adding a string. So we print that to the console just to see what it looks like. And then we again do our experiment by subtracting 1 from the length, which will return the number 2. And keep in mind that 2 is the last index of the array. So it prints that string again. And notice that nothing's been added at index 0 and 1, and that's fine. Space has just been saved and allocated, so we can add that at any point in time that we'd like. I'm Jasmine Greenaway, and I'm a cloud advocate at Microsoft. Let's work with data in arrays. You can add data to an array while it's being created or after it's already created. If you decide to add data after, be mindful of the index so that you don't overwrite any data that you might already have in your array already. If you want to access data in an array, reference the value by its index. This example shows an array that's been created with 3 values inside of it. The index always starts at 0, so that means the first value will always have an index of 0. And the next value will be an index of 1, and so on and so forth. This example starts with an empty array of a length of 2. Next, we insert a value at index 0. Then, we reference that value at 0. Notice that when we try to reference the value at 1, there's nothing in there, and it shows up as undefined because we didn't add any data there yet. The length and index of an array share an interesting relationship. An array can be created with a certain length and have no values added to it yet. This just means that space has been saved for values to be added at some point in the future. The first item in an array always has an index of 0. This means if an array has a length of 1, that first item in the array has an index of 0. The length will always be larger than the index because the index starts at 0. In fact, if you subtract the length by 1, you'll get the index of the last item in an array. This example shows an array with a length of 3. Nothing exists at index 3, so it prints undefined. but the value 5 has an index of 2 and is the last item in the array. So if I subtract 1 from the length, I get 2, which is the index of the last item, which is that value 5. This example creates an empty array with a length of 2. A value is inserted at index 1 and is then printed. It also happens to be the last index of the array. If we subtract this array's length by 1, the index will be 1, which also is the last index of the array. Notice that if we print the value at index 0, there's no value there and it prints undefined. So the space has been saved, just no value exists yet. I'm Jasmine Greenaway and I'm a cloud advocate at Microsoft. Let's explore some methods for manipulating arrays. Push and pop will change values at the end of the array by adding them with push or removing them with pop. Shift and unshift do the same thing, except it modifies the front of the array. When you use push or unshift, it'll return the length of the array with the new value. When you use pop, it returns the value that you just removed. Same thing with shift. With concat, you can join two arrays to make an entirely new array. In this push and pop example, we add a string to the end of array 1, and that returns its new length. With pop, we remove that exact same value, and it returns the value that we just removed. In this shift and unshift example, we add a value to the front of array 1 with unshift, and we get its new length. Then we use shift to remove that value from the front, and it gets returned to us in our console.log. In this concat example, the new array variable is a combination of array 1 and array 2, while new array 2 is a combination of array 2 and a new array that was created inside of concat. Hi, I'm Jasmine Greenaway, and in this demo, we're going to work through some array methods. One thing to keep in mind is that these are just a small set of functions and methods that work with arrays. There's a lot more, but these specific ones are going to be great for array manipulation, changing the data inside, and things like that. Here on line 1, we're going to use array 1 throughout this demo. In this first example, we're using the push and pop function. So on line 5, we add a string to array 1, and then we print it to the console. Notice that when we use push, we get the new length of the array. So that includes a new value. Pop will return the last item in the array and remove it from the array. So if I print it, I see that that string is now gone. Now let's do the same thing with shift and unshift. So unshift will add the new value, except it adds it to the front. So when I print it here on line 13 and I look at it in the console, I notice that the string is in the front of my array now. And when I use a shift method, it removes the first value from the array. So now that string is gone when I print it again to the console. Moving along to concat, here we've created a new array called array2, and it has 3 values in it. And what we're doing is just merging 2 arrays together. So we use that array1 variable that we've been working with throughout this demo and concatenating it to array2. And what we get is array1 followed by array2. So all the values in array1 show up first, and then all the values in array2 show up next. On line 21, we do the same thing with array2. So now array2's values show up here first, and then we've created an array here in concat to add this array with values 1, 2, and 3 to array 2, merge them together to make a whole new array called new array 2. And then we just print them to the console. And that's what we're seeing here.
Hi there, I'm Christopher Harrison. I'm a senior program manager at Microsoft inside of Cloud and AI. And in this section, I want to take a look at loops in JavaScript. So loops, of course, will give you the ability to execute some block of code multiple times. And you might need to loop X number of times where X is maybe a hard-coded value, or it's a variable that you have in memory. Maybe you need to work through a list, or maybe you're doing something like calling a helper function that's just going to keep giving you items back. And then once it's done, it's going to give you a null value, or it's going to give you a false. Well, depending on all of those scenarios, JavaScript is going to have the right tool for the job. Now, JavaScript actually has multiple types of loops that you can take advantage of. In our case, we're going to take a look at probably the three most common, which are the while loop, the for loop, and the for of loop. Not for each. More on that in a couple of minutes. Now, as I go through this, what you're going to notice is I'm going to walk through the same scenario 3 times. And the reason that I do that is because I like to be able to kind of draw a line between all of these different types of loops. So that way you can see a little bit of compare and contrast, and then hopefully in turn start to see a little bit about where where different types of loops are going to work better based on different scenarios. So let's start off by taking a look at the while loop. So you'll notice my scenario. I've got an array here with 3 different names, and I want to print each one of these out. Now, in the case of a while loop is going to execute some bit of code while something is true. So I need to set all of that up. The way that I'm going to do that is by first setting up an index. That's going to allow us to mark where we are inside of the array. And then we're going to set up our Boolean condition. So we're going to keep doing this for as long as our index is less than the length. Or in other words, we're going to keep doing this as long as we don't have any items left. Now, the big catch with a while loop is the fact that if you don't change the condition, it keeps doing the same thing over and 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 over again, which can obviously get a little bit annoying, as you just experienced there. So the most important component of setting up a while loop is making sure that that condition is going to change. Typically, this is going to be done because you're calling some helper function or otherwise that's going to eventually give you back a null or a false value that will indicate, okay, we're done, and then the while loop will see that and then exit. In our case, though, we need to make sure that we change index so that way, in turn, we're changing the expression. You'll notice that when I run the code, print all the values out, that we'll see Justin, Sarah, and Christopher. The next type of loop is a for loop. And a for loop and a while loop, especially with that last scenario that we had, are actually very similar. You're going to notice, just like before, that we need to declare our starting value. You're going to notice, just like before, that we're going to have some Boolean expression. So it's going to stay inside of that for loop as long as that is true. And then you're also going to notice that we're going to increment that index. So really, it's almost the same as before. The only major difference here is that with a for loop, my syntax gives this to me all in one straight line. And then also, just like before, we're going to go grab the current name and then print that out. And then our result would be the exact same. The great thing about a for loop is the fact that it's really built to execute X number of times. So if you happen to know how many times, or in our case, we can determine this programmatically by looking at the length, this could be the right loop for you. Now, the last one that we're going to look at is the for of loop. Now, a lot of other programming languages have something similar. In Python, this is simply a for loop. In, say, C#, this is a for each. Now, I do want to highlight the fact that in JavaScript, there is a for each, but it doesn't behave exactly the way that you might expect from other languages. That what it's going to do is look at all keys inside of an object and give you those back. And sometimes that can actually be quite helpful, but just not for our scenario here. Now, when you look at the for of syntax, what you're going to notice is that we're going to declare that variable name and then just simply say of names. And if we take a step back here and take a look at our for loop, what you'll notice is that we had to grab an index and then always go grab the current name. Same thing is going to hold true with our for of loop, except I don't actually have to do it. The runtime is going to do it for me. So what's going to wind up happening here is it's going to go grab the first name of Justin, the second name of Sarah, the third name of Christopher, and then print each one of those out. I don't have to worry about incrementing a value. I don't have to worry about an indexer, anything like that. So with that in mind, let's talk a little bit about where you might want to select each loop. So a while loop is great if you're going to be calling some helper function that's eventually going to give you back a null value. So I don't know how many times I'm going to execute this. I really have no way that I can calculate this. I'm depending on something to eventually change the condition for me. Perfect for while loops. Our for loop is perfect for executing a known number of times. That could be hard-coded. That could be coming from a variable. And then last but not least is our for of. And our for of is going to be perfect when we have an array or some form of a collection. Okay, so that's the concepts of loops. Let's go ahead and take a look at all of this in code. Hi there, I'm Christopher Harrison, Senior Program Manager at Microsoft inside of Cloud and AI. And let's take a look at how we can code with different types of loops inside of JavaScript. So I've got my code editor up here. I'm going to take a look at those same three loops that we've seen, which is our while loop, our for loop, and our for of. And just like before, I'm going to do the same demo 3 times. Now I am going to use some slightly different variable names as we go through this, just because I'm going to wind up running into a couple of little scoping issues. So I'm just going to use different variable names to avoid that. So let's go ahead and start with our while loop. So let's say console log and our while loop. There we go. And let's also make sure we set up our array, const names equals, and let's go ahead and say Justin and Burke and Sarah. Beautiful. Okay, so now I've got my my console log, and let's go ahead and start to write our code. So I'm going to say let's not do that, but let while index equal to 0. And again, keep in mind that the reason that I'm doing this, that while index, is just to make sure that this is different from the other indexes that I'm going to be declaring here. So I'm just avoiding some scoping issues. Okay, so I'm going to say while, and then our while index is less than names.length. And one big thing that I always like to do if I'm going to be the one responsible for changing the expression on a while loop is write that code first. Because if I don't, I'm just going to forget it. So just start there. And now I'll sneak back up to the top here and I'll say const name equals, and we'll say names, and we'll go ahead and grab based on the while index, and then console.log, and then the name. Cool. And so now if I run this app.js, what you're going to notice is I'm going to get Justin, Burke, and Sarah. So it's going through all the different items. The next one that I've got, so let's go ahead and say console log is our for loop. Boom, boom. And now I'm going to say for, and then I don't have to declare the index outside. It's actually going to give me the syntax to do it right here. So I'm going to say let for index equal 0 as long as my for index is less than, in my case, my names.length, and then finally for index, and then make sure we increment that with our plus plus. Okay, cool. So now I'm going to go ahead and say one more time, const name equals names, and then in my case this is going to be the for index, and we'll go ahead and say console log and then the name. So it's going to give us the exact same results. The big thing that I want to highlight, just like before, just like I mentioned in the prior section, is the fact that I don't need to declare the index separately, that I can do that all in one shot right here. So kind of convenient, kind of nice for that. Now, admittedly, if this is what I'm trying to do, which is to iterate through an array, the one that I'm going to use most frequently is going to be a for of loop. Now, I'm actually going to take a little bit of advantage of Visual Studio Code here, because you'll notice that we've got these little built-in snippets here. And so I can actually just, once I select this, hit tab, and then it will automatically give me the appropriate code that I want here. So I'm actually going to say const name of my object, which is going to be my names, and then one more tab, and then now I can go ahead and say console.log and then print out the name and hit save. And voila, I've let Visual Studio Code go ahead and write some of that code for me, which is pretty cool. So you'll notice that I've got all of that done. Let me go ahead and hit save, and then go ahead and execute that. And then you'll notice down here at the bottom is that for of. Now, one thing that you may have picked up on here, and I just want to call this syntax out, is you may notice right here that it said const name, and you might be thinking to yourself, wait a minute, it's a constant. I'm not able to change that. One really cool thing here is it's going to be constant for just this scope. So it's going to change each time I go through here, but if I tried to say name equals some value, this is going to wind up giving me an error when I run this because it's declared as a constant. So I know that it looks a little bit funny with it sitting there, but believe it or not, it is actually going to still work. And it's actually the preferred mechanism for doing this because it's going to keep you from making a mistake and accidentally changing that by yourself inside of a for loop, which is typically not what you're going to want to do. You're not going to want to reassign the value. You might want to change something on it, change a property on it, but as far as reassigning it, that's typically not something that that you're going to want to do. And again, same results as before. And so that is the 3 most common loops inside of JavaScript. That's our while loop, our for loop, and our for of.
My name is Nithya Narasimhan. I'm a senior developer advocate on the Microsoft Developer Relations team, and I'm here to talk to you about JavaScript functions. we're going to cover 5 things you need to know when you talk about JavaScript functions. Let's get started. First, what are functions? Functions are basic blocks of code that are executing a series of statements that you tend to use over and over again in your program. By abstracting these into a reusable function, you end up getting 2 benefits. We're going to talk about that in a second, but there are a couple of examples of functions that you see right here. In the first case, you have a function that just prints a very common message. In the second case, you have a function that actually computes a result given 2 inputs. Keep these examples in mind. Why are functions useful? Because when you have code like this that you use again and again and again, by abstracting them into a function that is reusable, you get 2 benefits. First, you get readability and conciseness. Think about a task that takes 10 lines of code that you use 5 times in your program. That's 50 lines of code right there. By abstracting it into a function, you can potentially reduce it to the 10 lines of code for the execution of the task and 5 invocation statements. From 50 to 15. The second, which is actually the more appealing use case for me, is maintainability. In this example, you can see that I wanted to change how I wanted to do something with the compute price function. If I had kept to my original intent of having that code replicated 5 times in my program, I would have to go back and make this change at every single location. By abstracting it into a function, I only have to make the change in one place. That makes the code maintainable by anyone who has to come and take care of it even after I've gone. So let's move on to the second thing you need to know. What does a function syntax look like? How do you define one? This is an example of a function in JavaScript. I've highlighted it in different colors so we can quickly talk about the different components of a function definition. The function keyword in blue is what identifies that code as defining a function in JavaScript. The most important thing you want to recognize here before we look at the other components is the curly braces that are highlighted in yellow that kind of scope out the statements that form the execution part of the function. Next, pay attention to the fact that this function has a name in green, and the name is what you use to actually execute or invoke the function. This is just the definition. Third, we have parameters, here shown in red. Think of parameters as placeholders for the input data that you need to pass to your function. Finally, we have a return statement. A return statement provides 2 kinds of value to you. We're going to talk about this in just a minute, but think of return statements as a way for you to ship data out or provide a result or output from the execution of that function. All right, so thing number 3. What we looked at there was the definition of a function. But the definition is not the same as invoking it. Think of the definition as a blueprint that tells you what the function does. The invocation is where you actually call it so it does it. So the big difference, when you define a function, you've got the little curly braces, there's no semicolon, you're really kind of giving a blueprint for the statements in the function. To actually execute it, you would invoke the name of the function with the curly braces, with the standard braces. Pass in any arguments if that original definition had any parameters. And that's it. So here, the print hello, to invoke it, you literally say print hello, open brackets, the actual instance of a name you want to provide, close brackets, and you get back the result, hello world. All right, item number 3. We talked about the syntax, we talked about invocation. Now let's talk about the different pieces. We talked about a function name. Function names in JavaScript are really about user-friendly, readable ways that allow you to immediately, at a glance, know what the function does, wherever you're calling it from. It's like variable names in terms of conventions. You can use any alphabet or numerical character, $signs and underscores, but no other special characters. Go try it out. We'll have a little demo video that shows you different examples, but go try it out and you'll see that if you were to use any special characters, you'll have errors in your editor. One interesting thing is functions are themselves objects. So you can use the function .name property to get back a string version of what the function name is, if for any reason you didn't know what it was. Finally, there's a special case known as anonymous functions that don't have a standard name. We're not going to cover that here. That will be covered in a different module, but feel free to go look it up online and learn a little bit about what anonymous functions are. All right, on to item number 4. We're really roaring through this, aren't we? Remember how I told you functions have a name? They can take parameters as placeholders for inputs, and they can return a result. Let's talk a little bit about the parameter side. Parameters are placeholders for input values. You can think of them as variable names that are used in the code, the definition of the function, as placeholders for the execution. When you actually invoke the function, you will pass arguments, actual values, that will replace every location of the parameter when you execute the function itself. Parameters are optional. You can have functions with no parameters whatsoever. For example, a print thanks function that just puts a nice friendly message. Anyone who calls it gets the exact same result. If you do pass parameters though, just know this. When you pass arguments to it during invocation, the JavaScript runtime does not actually check to see if the number of arguments you provided or the type of arguments that you provided match those of the parameters. What that means is that if you were to provide fewer values than were required, it's not going to tell you. It's just going to fill in undefined for every parameter that you have not allocated an argument or value to. So in this example, you can see in the compute price function, when I invoke it, it actually takes 2 parameters, but I only passed in 1 argument. And as you can see from the result, the second argument was seen as undefined, and therefore I might end up with a slightly unexpected result. So one takeaway for you is if you are using functions that have complex execution statements, make sure you validate your data or you validate your arguments as part of the function definition. And we're down to the last point, and this is the return statement. So one thing you need to know about functions is those curly braces, they enclose the execution statements of the function. If you did not have a return statements are absolutely optional, your function will exit by default when you get to the final curly brace. At that point, it returns back to whoever called it. However, I usually recommend that you do have a return statement. Return statements have 2 really useful value propositions. First, they give you a very clear idea of where your function is going to exit. This is particularly useful if you have conditional statements. If within your function, you're saying, based on this input, I want to do this, this, and this, or based on that input, I want to do that, that, and the other. In this case, you want to have return statements so that when you finish executing the correct path, you exit the function without going and doing things you shouldn't have done. The other useful value proposition for return is it allows you to provide an output result that gets returned back to the caller. So this is a great way for you to provide results based on the computations or execution of tasks that you did. In this particular example for compute price, we're using the return statement to return the value, the computed price, based on the cost of the item and the discount that has been provided. Again, if you didn't have a return statement, by default, the value returned is undefined. So you'll see in the example there that when I call compute price with the right values, I get a proper result. But when I call print hello, which doesn't have any parameters and has no return statement, I simply get back undefined. Well, that was 5 things you hopefully learned about JavaScript functions today. What functions are, why they matter, your naming conventions and tips for naming them, what function parameters do for you, and last but not least, why you need return statements. See you on the next module.
Hello, my name is Nitya Narasimhan. I'm a senior cloud advocate at Microsoft. And today, I want to talk to you about 5 things around JavaScript functions that you can explore with code. Let's get started. So first, what's a function? A function is nothing more than a block of executable code. By making it into a function, you now have this become a reusable execution block, which you can call from anywhere, which makes your code easier to read and easier to maintain. So how do you actually define a function? The easiest way in JavaScript is by using the function keyword, followed by a very simple function name. So in this case, I'm just going to call it print hello, followed by simple brackets, open curly braces, close curly braces, and that's it. The execution, the task statements that you're thinking of, that would go in here. Now, in our simplest form, for now, I'm not going to define anything. Is this a function? Let's check it out. I'm going to log this function to see what it prints. And remember, at this point, it's actually printing the definition of that. So it's going to look at what type. Oh, actually, I wanted to print what type this was. Let's save that. And you can see that this is of type function. So just the simple thing that we did, the simple definition, is a legitimate function. It just doesn't do anything, right? In order for it to make it more interesting, let's actually add an execution statement. So I'm going to do the usual thing of just logging something to the console so we can see it. So we're going to do the ubiquitous hello world. And if I execute this now, do you expect to see hello world? I hope you said no, because we have defined it, but we haven't invoked it. Definition just is saying, this is what this function will do when it's called. Invoking it is actually calling it. So now we can look at function invocation. How do we invoke it? Simple. You use the name of the function, open close brackets, and then semicolon. That's the important part. That makes it an execution statement. Now you see hello world. And the reason, one easy way that you can think about remembering to put these brackets is that think that this function name, when you execute or invoke it, you want to pass in inputs and you want to get back a result. You need some way to pass in inputs, right? That's what those brackets are for. They're like a container through which you pass in arguments that get mapped onto the parameters of the function. We'll talk about that in just a second. But until then, let's first look through naming conventions. Turns out you can use any alphabet. For naming conventions is for the function name over here. You can use anything for a function name that is with alphabets, numbers, $, and underscore, but no other special characters. So in here, if I try to make this print $, it will work, right? So I'll change it in 3 places because I don't want it to scream at me. And if you look at this, that works. And you can take my word for it that it'll work for underscore as well. But let's try a special character. What if we try to say, make it print hello? Just using the character itself causes the editor to tell you this doesn't work. You can see those little red squiggly lines, right? So that's all you need to know about naming. You can use numbers, alphabets, underscore, and $. Everything else, not a valid function name. Great, we learned about function names. Now we come to the interesting part, parameters. So if I look back at this function, print hello, I actually say want to execute something and I want to provide it data that makes that execution a little bit more personal. So in this case, rather than say hello world, I actually want it to say my name. How do I do that? So I can do that by first making sure that there's a variable called name that has this data that should be replaced by the actual name, and then using parameters. So think of parameters almost like placeholder variables through which you can pass data into the function. And at the time of execution, the placeholder gets replaced with the actual data. How can I test this? I'm going to stop printing the type of, we already know this works, right? So how do I invoke this? When I have a parameter defined, I can now go in and pass the value for that parameter in here. So let's say I make this Microsoft, right? And now you can see it prints hello Microsoft. So this is simple. This is awesome. So we can also play with it just a bit. Now that I've defined a name, what happens if I don't give it a value? What do you think is going to happen? Let's try it out. So what this means here is like I've defined a function and I've said I expect a parameter, a name, and I invoke it without actually providing any arguments. It'll still run. It'll just come up undefined. That's because JavaScript doesn't actually validate to see whether you're using the right number of parameters or the right type of arguments, number or type of arguments, sorry. It'll just execute it. So what that means is I can also do the equivalent of, say, Microsoft, and then put in comma, and then put in a second thing. And what this will do is it'll effectively just ignore the second, right? And it'll just use the first thing as the argument for name. So far, so good? Great, all right. Now, let's think now about return statements. So parameters, you're able to pass input, but what if I want to get output out? Return statements have two value propositions. One is they tell you where the exit points in the function are. It's like saying, when I see return, I know that I'm going to stop executing those statements inside that function block and get back to the caller. But it also, as part of that exit, lets me return data. Now, the first thing I'm going to do is let's assign a result to print hello. And we'll use the Microsoft example, just so it's kind of cool. Right? So in this case, all I've done is said, hey, if this function returned a result, it's going to get assigned to that variable, right? And let's print this variable out and see what happens. Note that right now I'm not actually returning anything in the function definition. So what happens? It comes out undefined. Totally legit. So in this case, there was no return statement. Nothing was returned as a result. The function exited gracefully on the last statement, which is the print, returned and said, hey, there was no result, undefined. Great. If I were, however, to put in a return statement, I can just say return. I haven't returned a value. It'll still be undefined because I haven't actually returned anything. It's just, I still like putting return statements because it's now very clear where your function exits. If I were to return an actual value in here, so let's say I return, for the sake of it, let's say I return name, and then I add another name to it. Name, hello, right? Another string to it. Now, when I print this out, you'll see that that string, whatever I created, was returned as a return result, right? So we've learned a bunch of things today with just this simple demo. First, we understand what functions are. We understand how to define them. We understand how to invoke them. We understand what parameters are and how to pass in data through parameters, and what happens if you don't provide the right type or count of arguments. We also understood what return statements do and how to use those to pass output data back to our calling function, to our calling code. I hope that was useful. See you at the next demo.
Hi, my name's Aaron Powell. I'm a Principal Cloud Advocate here at Microsoft, and today we're going to talk about arrow functions in JavaScript. An arrow function, or something you might be familiar with, a fat arrow function, is a special type of function declaration that we've got in JavaScript. A function is normally defined using the function keyword, but an arrow function is defined using an equal symbol and the greater than symbol following it immediately. That's why it gets its name, fat arrow. The special thing about an arrow function is that it changes the way that the this context is managed within inside of a JavaScript function. If you've worked with JavaScript functions before, you might have seen that the this value inside of that function is determined by its parent scope. So it can catch you out on where that function was called to what this actually represents. Inside of a fat arrow function, it captures its parent's this context and makes that available, because an arrow function doesn't have a this context of its own. Instead, it inherits it from its parent, or its parent's parent, or its parent's parent, etc., depending on where the most top level non-arrow function is defined. An arrow function also supports implicit return values. This means you don't need to use the keyword return to return a value out of an arrow function if it's only a single line. An arrow function can also be assigned to a variable, so we would do const add equals and then our arrow function, or it can be immediately used. We can't just have a named function like we would with a traditional JavaScript function because it has to be assigned to a variable. One of the other benefits is it's a reduction in the number of characters you've got to type, or the number of characters that are in the output JavaScript, and thus a smaller bundle size you might be sending down in a browser response. Let's have a look at a couple of different use cases for an arrow function. On the first set of examples, we'll see we're creating an add function. We're assigning that to a variable called add using a const keyword, and then it has two arguments, a and b, and then our arrow keyword, or our arrow operator, sorry, and then a plus b. Now this doesn't have a return statement, and it's also only a single line, which an arrow function then deems as an implicit return value. So when we were to do a console.log on that add function, it will give us the value of 3. Now we can still have a multi-line and explicit return for our arrow function, and that's what we're doing with our subtract variable. So subtract is assigned to an arrow function, and this time we're using the curly brackets to denote that this is going to take multiple lines. And here we then have the implicit return, the explicit return, not an implicit return, by using the return keyword. Now you could imagine you could have other things that this function is also doing, but in this case, it's still only a single line. And then if we were to call it, we would call it the same way we would call the add function, just by invoking that function and passing in some arguments. As I mentioned before, the this context changes with inside of an arrow function, and it's important to understand what that means. This context in a traditional JavaScript function is defined where that function is called, whereas in an arrow function, it's inherited from its parent. So if it is invoked inside of the callback for a callback handler, such as a click event or an asynchronous operation, then it will be wherever that function was defined as passed as an argument to the callback, that is where the this context will be. This means that inside of an arrow function, you're less likely to rely on this because it's always inherited somewhere up in the hierarchy of the definition of that function, and it's not something you can control with inside of your own scope. Because you cannot actually change the way that this context is defined with inside of an arrow function. In other JavaScript functions, you have some control over that, but this is always explicitly defined by its parent. And it's also maintained if you pass this function as a reference to another function. So this is where you would pass it as the callback handler to something that's going to happen asynchronously, whether it's a set timeout. This scope is always going to be defined by its parent, and it could be passing that so on and so forth to many different locations where you have so far removed from whether it was originally defined, but that this scope is originally captured from its declaration point. And if we're dealing with our return values, we can have them implicit or explicit. A single line arrow function will always be implicit returned, even if the result of the operation returns nothing, it returns an undefined. Then the return value of your implicit statement is going to be undefined. If you want to make an arrow function over multiple lines, then we would use the curly brackets. That would then denote the start and end of the block that is that function, and then everything within inside of those curly brackets are the block statements that we have. This is similar to a traditional JavaScript function. Hi, my name is Aaron Powell. I'm a Principal Cloud Advocate here at Microsoft, and today we're going to have a look at some demos of how we can use the arrow function, or the fat arrow function as you might also know it as, in JavaScript. I'm going to start by declaring a fat arrow function in JavaScript. Now we have to do that by assigning it to a variable. So let's create one and we'll call it add, at which we'll take two numbers and add them together. So we'll take two arguments, then we use our arrow characters, so which is the equal sign, and then the greater than symbol. And in my text editor and using the font that I've got, it actually looks like an arrow, and this is where it gets its name, fat arrow. And then in this, we'll do add A and B, so using the plus operator to combine them together. And now we can do console.log, and this is then used just the same way as you would use a traditional function in JavaScript. We'll do add, and we'll do 1, 2. So if we save this, and then we'll run it from here in our console, and we get, as we expect, 3 as the output. Now what's interesting about the arrow function that I've defined here is that it's got an implicit return statement. I haven't had to use the return keyword to make this happen. I've just added those two together. And this is because in a single line JavaScript function that's defined using the arrow function syntax, it is going to be treated as an implicit return. So whatever the result of the operation you've got on this line is going to be returned as the output of that function. This does mean that you can't do things like declare a variable with inside of an arrow function that doesn't have a multi-line feature enabled for it, because you don't have the ability to do a variable declaration and have that return something. That would be invalid syntax. We can still create an arrow function that does work across multiple lines. So we'll create a new function. Oops, not console.log, we'll do const. And we'll call this one subtract. And we'll take an A and a B. In this case, we're going to use the squiggly brackets to create a block. And inside of this block, we now can treat it like we would a traditional JavaScript function. We can have multiple lines. So I could do const result is going to be A minus B. And then we can return using the return keyword and return result. Now, in a multi-line arrow function, we have to be explicit about our return using the return keyword. This is because it's treated then like a normal function block, and we don't know where that function might end, so we use the return keyword in that case. And also this means that a multi-line JavaScript function defined with the arrow syntax can also not return a value. Well, in true, it will actually return undefined implicitly because a function that doesn't use the return keyword won't return a value. It will return undefined. So if we do console.log of subtract 1 and 1. Now if we do console.log and run our demo, we'll see that we get 0. So we get what we would expect. And our function works the same as we would with any other functions in JavaScript, just we're able to use the arrow syntax and take some advantages of some shorter character count in maybe our response if we're sending this down in a browser, or fewer keystrokes if you're a little bit of a slacker developer like myself. But also we have the ability to do implicit returns by having a single line function with no squiggly brackets around it to denote a function block. But we can still have multiple lines if we so desire and we need to inside of our function. So that's a quick look at how we can use functions using the arrow syntax in JavaScript. See you next time.
My name is Nithya Narasimhan. I'm a cloud advocate at Microsoft. And today, I want to talk to you about JavaScript object notation. There are just 4 things you need to know. So let's get started. First, I want to set some context for why JSON is useful. It turns out that JavaScript is actually used extensively in web development today, where you have client-server applications. You might also be familiar with its use in Node, where you have many cases where you need to read and write data from the file system. Both communication protocols and file transfer protocols tend to rely on text-based formats for data transfer. This is where JSON comes in. JSON is a lightweight data exchange format that is language independent and user readable. In fact, in the example on the right side, you can look at what a JavaScript object literal, in this case, a book with 3 properties, title, author, and is available, looks like when it is converted into an equivalent JSON string, shown below in black. Pretty readable, right? So JSON is a language independent format because any modern programming language that supports 2 kinds of data structures can use JSON. The first is name-value pairs. Any programming language that supports the ability to have a collection of name-value pairs. And in JavaScript, this is probably very familiar to you. Doesn't that look like an object with properties? The second data structure is an ordered list of values. While name-value pairs let you serialize a single object, if you want to pack multiple objects into a single string, you need an array. These 2 data structures are supported in most modern programming languages. Here's what that looks like when you use it with JavaScript data. So the JSON format effectively is name-value pairs for a single object. It encloses name-value pairs separated by commas within curly braces as shown in the highlighted yellow. When you have multi-item or complex arrays serialized, it encloses all those multiple objects, again separated by commas, inside square blue brackets. Both of these are very user-readable strings. But how do you convert between JavaScript objects and JSON? Well, you just need to know 2 methods. First, objects to JSON. You stringify them. That's easy to remember, right? Because you're converting into string formats. What I want you to look at in these 2 examples, the first one serializes a JavaScript object into a single text string. The second serializes a collection of JavaScript objects into a text string which represents an ordered list. What I want you to pay attention to is both of these use the exact same method, json.stringify, and pass in a reference to the data that you want serialized, whether it's an object or an array. You don't need to have any kind of difference between them. Once you've stringified it, how do you then deserialize or restore the original objects from that? Well, just remember json.parse. So again, if you have a serialized string, you don't even need to know whether that came from an object or a collection. Simply pass it to json.parse and it'll return you a reference to a JavaScript object or possibly an array. Using typeof with that returned result will let you know the difference between the 2. But what I want you to kind of look at here is that the JSON string, once deserialized, gives you an object that's effectively got the properties restored. What if you needed to have the object define the functions as well? JSON's not going to do that for you. The best way to do that is to have
a constructor that's capable of taking the properties and its data that's serialized and then restoring it to a complete object with the functions defined as well using a custom constructor. With that, that's literally all you needed to know about JSON. So hopefully you got to understand what JSON is, what the JSON format looks like, how to convert JavaScript objects to JSON, and how to restore a JavaScript object from a JSON string. Hope that was fun. See you at the next module.
My name is Nithya Narasimhan. I'm a senior cloud advocate at Microsoft. And today I want to talk to you about JavaScript Object Notation, or JSON. Let's get started. To set some context for why you need JSON, let's first think about JavaScript objects. Here we have a very simple example of a JavaScript object. And if I were to just print that out and look at its type, you can see it's an object with two properties, title and author. And when I actually print it out to the console, you can see that title is the name and the value 1984 and George Orwell are strings. Great, nothing new there. Now let's think about collections of objects. It's actually very similar. So if I were to do this again, now we can see that by printing out the contents of an object collection, in this case an array, that really is an array of objects, each of which is a collection of name value pairs. All of them have the same properties, they just have different values. Simple. Here comes the issue. Let's say you actually want to use this data for some kind of a request you need to make over the network. Maybe there's a library API that you need to hit, and this is the data you need to give it to let the library know that the users checked out these books. Or you might want to store it to your file system. Turns out that many of these file transfer and communication protocols require request response messages to be in text format. So we need some way to take this data from JavaScript and convert it into strings or text format that can be used in messaging over the network or in transfers to a file system. This is where JSON comes in. And you're very lucky because JSON just has two methods you need to know. The first one is called stringify. Let's take a look at what that does, and then we'll talk a little bit about it. So in this, book.json is effectively giving you the result of json.stringify called on the book object, right? So in effect, json.stringify is a method that takes an object and returns back a stringified form of it. And you can check, like when you look at the type of book.json, it's a string. And when you print it out, you can see that it's effectively nothing more than a list of name value pairs, but both names and values are stringified. So effectively, this is in complete text readable format. And guess what? I don't even need a different method API or method call if I'm using an array. It's the exact same format. So let's try this out. I just call json.stringify on the mybooks object, which is effectively an array of, or a collection of book objects. And voila, I have a stringified flattened format of the contents of that array. And you can see in here that the stringified format effectively represents the array, and then the individual objects in the array separated by commas, just as you would expect. The most important thing about JSON is you can see it's user readable. You can look at this, and even if you didn't know anything about the program, you could understand that this is a collection of books. So this is great. You were able to now take JavaScript objects or collections of objects and flatten them into a single string that contains all the data in those objects. But what if you wanted to do the reverse? Like once you've got it in JSON, how do you get your objects back? That's why you need to know method number 2. And that is called json.parse. Let's take a look at what that does. So in this case, all I've done is I've taken the string that we got in the previous method when we stringified an object, taken that string, and you could have gotten a JSON string from anywhere, and given it to the json.parse method, and then inspect whatever it is that we get back as a result. So in this case, first of all, let's log what we get back as a result, and you can immediately see that you get back the exact object that we had parsed for book, right? So it's title, author, and the values for those two properties. Second, I did a call to see, array is array parsed, which is effectively checking to see if this returned object is an array, and it's not, which makes sense because it's a single object. Third, I looked at how many items were in there, and since this isn't an array, this is undefined. So perfect. Why did I do all this? Because guess what? The one thing about JSON.parse is you don't need to know the string coming in. You don't need to know ahead of time whether it comes from a stringified form of an object or a stringified form of a collection. It's going to be the exact same call. So let's try this out with the array. In this case, what we're doing is we're parsing mybooks.json, which, if you remember, was obtained by stringifying a collection. So effectively, it's a string that represents a collection of objects. Just pass it to the exact same method. And now, when we call these methods, let me scroll this up so you can see all the data. When we actually call this, you can see that the data that it returns is in fact the array of objects that was serialized in the first place. When you do an array is array, you see that it comes out to be true. The number of items tells you that there are 4. In effect, that string that you had has now been deserialized back into an array of objects that you can now work with in JavaScript. And this is all you need to know. JSON.stringify to convert objects into JSON strings, whether they be single objects or collections, and JSON.parse to now take that stringified format and revert it back into either an object or an array based on what you were packing in the first place. I'll just leave you with one final thought. This is just looking at very simple objects. You should play with a little bit more in terms of examples. But let's say you wanted to take data from an object that had both properties and functions. You can still serialize it to JSON, which would serialize the data, and then revert it back into the object. At that point, you could have written object constructors that let you take JSON data and reinstate the object with the additional functions and everything defined in there, and only the data initialized. That's all I had to say about JSON, and I hope this was interesting. Look out for the next demo video. See ya. My name is Nitya Narasimhan, and I'm a senior cloud advocate at Microsoft. Today, I want to talk to you about JavaScript objects. In fact, I have just 6 things to tell you. Let's get started. First, what are objects? You encounter a lot of objects in the real world. You have books that are in libraries. You have songs that live in playlists. Each one of these has 2 different things that make them useful to us. First, they have attributes, data that describe them. So a book has a title, an author, and maybe if it's in a library, it has a status that tells you whether it's available or not. Similarly, they have actions you can take on them. So you can check in or check out a book from the library. JavaScript objects are a way for you to represent these real-world objects in code. So rather than attributes, we refer to them as JavaScript object properties. Properties are effectively those attributes that describe that object. So in this case, in green, this particular object called book has 3 properties. It has a title, an author, and a flag, a status flag that tells you if it's available. Objects also have methods, similar to the actions we talked about. In this case, in red, you see that this object has 2 methods, check-in and checkout, which effectively manipulate the value associated with the availability status. The one thing you can take away from objects looking at this definition is that properties are simply variables associated with the object, and methods are simply functions associated with that object. Next, let's think about the object syntax and its creation. In the example I've been using so far, this form where we've kind of created an object by simply using the curly braces and enclosing a series of name-value pairs separated by commas, that particular form is known as an object literal because you're creating and defining it at the same time in the same statement. But what exactly is an object? An object is nothing more than an unordered collection of name-value pairs. In this case, those name-value pairs consist of the properties of the object as well as the methods. Properties in green, when you saw them before, and methods in red. The object literal, what you see here, is the easiest way for you to create an object. Simply open curly braces, list out all the properties and methods of your object, close curly braces, and you've declared yourself a new object. The other way you can create objects is by using what's called constructors and the new keyword. An object constructor is, you can think of it almost as a template or a blueprint for an object. It tells you what that should look like, but that's just a definition. In order for you to actually create an instance of that template,
you use the keyword new, which effectively stamps out one example and fills it with data. So in this particular case, we're using the base template called hello object, and you can create yourself an instance of any object by basically saying, in this case, book equals new object. Now you've stamped yourself an instance of that vanilla object, and you can now associate it with your custom properties and methods, exactly as shown in the example here. One thing you need to take away from this is we've had two different ways for you to create objects, but once created, they're going to behave exactly the same. So pick your path. When starting out, you might find literals very easy to use, but as you skill up, constructors have a lot of great properties that are going to make it easier for you to do things like inheritance. We're not going to cover things like function constructors and prototypes in this particular module, but if you're curious, go check those out. Great, so we've created this object, but chances are you want to use those properties or invoke those methods, right? How do you do that? Let's start first by talking about properties. Properties are basically the attributes of the object, if you will. They have immutable names and mutable values. What that means is once you've assigned properties to an object, you can change the name. You can remove the property, but you can't go and alter the existing property name. However, you can alter its values. And you can do that using one of two different notations. You can access and modify them. To access a property, approach number one is to use what's called the dot notation. If you're familiar with namespaces, this format is actually likely familiar to you. It's object dot property name. So in this particular case, if I say book dot title, I'm effectively going to get back the value associated with that property, which is 1984. I can also say book.title equals and give it a new value if I want to, which will effectively change the title of that book. The second notation, which sometimes is harder for people to wrap their heads around, is known as the bracket notation. And it's easier to remember if you think of the fact that properties are effectively like hash maps. They're a key and a value. So with the bracket notation, using object name, brackets, property name as the key, which in turn will go and fetch back the value. So in this case, I can say book, square brackets, title, and note that the title is in quotes, will now return to you 1984. Make sense? Hopefully. Remember, we also talked about methods. Methods are simply special properties whose type happens to be that of functions. In other words, a method is simply a function definition associated with that object. If you look at the two examples here in red, check-in and checkout, because methods are special properties, you can access the method definition exactly the same way, using either the dot notation or the bracket notation. So book.checkin will return you the function object. Book, square brackets, checkin will also return you the function object associated with the definition of checkin. That's about getting access to the function definition or object itself. What if you want to use it? Well, you invoke it just like any other function using regular standard parentheses. So in this case, book.checkin, open brackets, close brackets, will actually execute the code inside that function, setting the isAvailable property to true. And note that I can use either one of those notations. So I can actually use the bracket notation as well. Simply use the same way to access the property, access the function or method, and then call brackets on it to invoke it. Sound easy? I hope so. Last but not least, this is actually one of the most complex, at the same time most powerful concepts that you learn. If you remember looking at those method definitions, you might have seen an interesting keyword called this. So I've replicated part of that function definition here and changed it slightly so we can talk about it. So checkin in the function checkin, I don't say isAvailable equals true. I say this dot isAvailable equals true. What is this? This is really a keyword that sets the runtime context for the function. It's a way for the function to be able to get access to other data or functions in its runtime scope. So when we're thinking of methods, which are functions associated with an object, a method might want to look at other peer property values. If you think of standalone functions, a standalone function might want to prefer some global context data that's available in that runtime. The this keyword lets you do that. The interesting thing is this is bound to a different object at runtime based on context. So if you are using a method, this by default is bound to the object that represents the owner of that method. So in this case, if I use this, it'll return book. But if I'm looking at a standalone function, it maps to something called the global object. It's an object that represents the global runtime. We'll talk about that in just a second. There are some caveats though. If you apply strict mode, then unless you've explicitly set the value of this, it'll turn out to be undefined. And more importantly, we're not going to cover it in this module, but there are ways for you to actually specifically or explicitly tell a function what the this object is by using methods or by using functions like apply. Look those up if you're interested. But I'm going to stop with kind of like just one final thing about the global object. Remember I told you that if you're a standalone function, that this will refer to a global object? Well, it turns out that if you're using JavaScript in the browser, that global object is the window. But if you're using it in Node, it references an object literally called global that represents the global runtime. And it allows you to associate properties or methods with that global object and have them be accessed by other functions in that scope. Because the global object refers to different things, whether you're in the browser or in Node, there is actually a convenience, a keyword called global this that you can use in your code that automatically maps to the right global object without having you have to change your code. Hope that was useful. With that was our super fast introduction to JavaScript objects. 6 things that you hopefully learned. What are objects? What is the syntax of an object? How do you create them, either as literals or from constructors? What are properties and how do you access them? What are methods and how do you invoke them? And finally, what is this? Hope you had fun. See you at the next module.
My name is Nitya Narasimhan, and I'm a senior cloud advocate at Microsoft. Today, I want to talk to you about JavaScript objects. We have a lot to cover, so I actually preceded a little bit of code, and we're going to walk through this one step at a time. So some of the things you'll learn. How can you represent, what exactly are JavaScript objects? There are ways for you to represent real-world objects in code. So how can you do that? We're going to look at that in just a second. Real-world objects have associated attributes. In JavaScript, they're known as properties. Real-world objects have actions you can execute in them. In JavaScript, those are called methods. And last but not least, we're going to learn about this special keyword called this. So let's start. Since I have a lot to go with that, I actually preceded a little bit of code that we can execute one at a time, and then we can walk through it. First, we're going to look at how we can define a simple object in JavaScript. So I've uncommented the code, and I'm actually going to run it. And you can see that blank type, all I've done is define blank as open brackets, curly braces, close curly braces. And if I print that out, the type of this is object. So a simple object, the simplest object you can think of, is effectively a pair of curly braces with nothing in them. In reality though, an object is nothing more than a set of name value pairs that kind of identify the attributes and actions, in other words, the properties and methods of that object. So next, let's actually look at what that really looks like. So I'm going to comment this out, uncomment the next bit of code, and we can walk through this. So now what we're doing here is really actually providing some properties to this object. Properties are nothing more than name value pairs separated by commas. So let's look at what that looks like when we execute it. Oh, hang on. I need to save that. Now you can see that we have book type still being object, but when I look at the value of it, you can see that it's a series of name value pairs separated by commas. The names are title, author is available. Values, as you can see, can be strings, can be booleans, can be numbers. So at this point, we're beginning to give the object attributes, something that describes the data that you can store in the object. Next, let's look at what we want to do if we want to define actions on the object. So in this case, we're looking at a book, right? what if you want to actually change the status of is available based on whether someone checked in or checked out that book from the library? So in this set of code, again, let me just run it and then we'll walk through it step by step. You'll see still the same code as before. We have the same attributes, but now we have two additional methods. Methods are nothing more than functions defined or associated with that object. So I want you to pay attention to two things here. First of all, note that functions look just like any other property. They're also a name value pair. They're added in a comma separated way as well. And they are in fact just another legitimate property. They're just special properties because rather than have them associated with variables or data, we have them associated with function definitions. In this case, again, just as with regular functions, we'll see this later, you can invoke those actions by calling that particular method. So now we know how to define an object, a very simple object, give it properties, and define methods on it. The example you've seen here is called an object literal. And we're going to talk about that in just a second. So it is the simplest way for you to create objects in JavaScript. But what we want to do is we actually want to look at ways in which we can create slightly more, or we can look at other ways in which we can create objects as well. So in this particular thing, let's kind of first start by looking at what constructors are. In object literal, which is what you've done before, all you had done is declare the equivalent of a variable, assign to it empty kind of curly braces, followed by name value pairs enclosed within, right? And that created an object. It's literally defining and creating it at the same time. That's how I remember object literals. The other way to create objects is through constructors, and this is an example. A constructor, think of it almost like building up an object bit by bit by constructing things like adding properties, adding methods, etc. And object constructors are templates. They're like blueprints. Again, they define something. When you stamp them out using the keyword new, that's when you actually create an instance of the object. So in this case, we are using new object. Object is the base template for all objects. If you have to just define a vanilla object, that's what you would use. And now if I define book as a new object and I just print that, I'm going to see, let me actually comment this out here. Let's just see what book alone looks like. So in this case, we've defined book as simply a new object, right? No other property, no method. And you can see it's a book is of type object. Totally legit object just like before. Its values an empty set of name property values, right? But now, if we actually want to start filling data, we can do it in one of two ways. So the first way is you can take those name value pairs that you had. So in this case, let's just say I stick with two of them, the title and the author, create the equivalent of a container, data object container, and then use that as the argument for the new object constructor. So in this case, I've created this data variable and passed it in as the constructor. And now when I actually look at the output, I need to save that. You'll see that book one, this new type, is effectively a new object that's been created using those name value pairs I passed in. And now that object is exactly as before. You've got an instance of an object containing those properties. And you know where I'm going next. We've shown you how to do this with use a constructor with properties. You can now use a constructor that also provides in or takes in a data object that has functions defined, and your resulting instantiated object now has those functions as well. So till now what we've learned is you can create an object, or rather objects are collections of name value pairs. Those name value pairs can represent data, in which case they're called properties, or they can represent methods that you can run on that object, which are really functions or actions you can take. And you can create those objects in one of two ways, as object literals, where you're literally defining and creating it in the same statement, or using constructors, where you can build them up using this template and then attach more things to it as you go. So that actually, we've already covered quite a lot so far. Hopefully that was useful. Next, I want to just talk about properties and methods. And in fact, in that case, let's keep this one open so we can use this data object as our example. So this is great. We now have an object which contains, let's print this out. It contains 3 attributes or properties, title, author, and is available. And it contains 2 methods, check in and check out. How do I actually access them? This is great, I have this object, but how can I actually understand what that contains? So we have 2 different notations, and I'm going to start first by showing you how you use this with the properties. And then remember, methods are just special properties, so you can apply the same thing there, and we'll look at that in just a minute. The way you access it is option number 1, use something called dot notation. So in this case, let's comment this out so we can actually access the code here. Okay, in dot notation, what you're going to use is you will effectively take the object name. So in this case, we're looking at object 2. Dot. Now dot is just like, if you're familiar with namespaces, this will probably be very familiar to you. So dot and then the property name, in this case, let's say author, right? This should now print out the name of the author. There you go, George Orwell, right? So the dot notation is, remember, object name dot the property name, and that gets you access to that value. I can also change the value using the same property. I don't want to change it, but we will. Let's go and change this to say G Orwell instead. There, I feel better. I'm not totally lying. Haha. And now let's see if that makes a difference. And you can see that now when I print, let me clear this up so you can actually see it. And we'll print the whole book. How's that? Because then we can see whether we change the book itself or not. And now you can see that when I set the book2.author to the new name, the book object's value changed. So now the author says G Orwell. So this is how you use dot notation. Brackets notation is exactly similar in terms of what you can do. You can read or you can write data to those properties, but you're going to think of it almost like a hash map where the property name is like the key and your value is represented by using square brackets. So in this case, I'm going to just take these 3 statements and we will replace them here with brackets. So here, rather than use dot, I will use brackets. But remember now, these are keys. So I'm going to have to use a string because it's really the key name that I'm passing into this structure. So this is it's very similar to arrays if you think about it, right? So if you want to remember this, just remember that an object's name value pairs are like a hash map and the names are the keys. So now if I want to assign that, I can do the same thing. We'll test both these out in just a second. Okay, so let's look at what happens now. And as you can see, you're seeing the exact same result. So whether I use dot notation or whether I use bracket notation, I get the exact same outcome. Pick whichever path you choose, which one makes most sense to you. I tend to use dot notation a lot more because it's easier to remember. But we can also take this one step further. With this, you were looking at properties. Can I do this for methods? In other words, can I invoke a function? Turns out you can. And the easiest way for me to kind of do this is we'll just replicate one of these. And what I'll do is I will actually print the is available property because we know that there's a method that can change that. And then I will call the method. So let's say this is, was it checked in by default? Yeah, is available as true. So I'm now going to check it out, which should set it to false. And then we can basically see what is the status of is available now, right? Oh. Let's just print it. We'll come back and check this later. Okay. So I'm going to close or comment off all of these so we only see the output that we are looking for. So now when I use dot is available, you can see that the property had a value of true. And then when I check it out, I'm using the dot notation on the method name to invoke it. And as a result, you can see that now the is available status is set to false because I've effectively invoked that method. Now this is probably familiar to you, but know that you can use brackets notation for methods as well. So I'm going to take the same code. Let's comment. Okay, let's keep them both. We can then kind of compare and contrast. And in here, what we're going to do is we're going to use the bracket notation. So instead of saying, we'll use this part the same, but instead of saying book2.checkout, we are basically going to say square brackets, checkout, and now using the key to actually access it. And if we're right, we should get the exact same result. Let's see. There you go. So with that, the last thing we'll talk about today is the this object. So in all of the code that we've written so far, you might have seen us repeatedly use the term this. So like here in the function, within functions, we have this dot is available. What exactly is this? Think of this as a keyword. It is a keyword, a reserved keyword. Think of it as a handle to your runtime context within functions. So let's look at what that actually does. So I have two examples here. If we print it out, we can see what this is. So to kind of look at that, within this function, I'm just returning this. So it means that whatever was set as the runtime context for the function, I should be able to tell what that was just by looking at the object that's returned. And I'm doing it in two cases. In case one, I have a function defined within an object, and that, when I call it, returns it's this object. In another case, I have a function that is defined at the global scope, so not within an object, and I return whatever it sees as this. And let's first look at the data, and then we'll talk briefly about what this is. So if you look at this, in the first case, which is over here, this is effectively the object that is book itself. So as you can see, when I print out this is, and I call book.object.checkin, whatever it returns is that object definition itself. In other words, in other words, this represents the book. An easy way for us to check is to change this now to say, is this actually the book object? And it should be true. Hang on, trying to clear the screen so we can see it on top. Okay, so now you can see that when I check to see if the this object returned is the same as the book object itself, that's true. What this tells you is that within the function context of a method, this represents the owner, which is book. However, when your function is defined in the global scope or is not attached to an object, you see that what it returns is this kind of like longish object known as the global object. And the global object is the default object that you can attach things to in the global runtime. A simple way, if you kind of never remember what to call it, they have a dedicated keyword called global this that allows you to reference that object regardless of what runtime you're using, whether it's Node or browser. So in the browser, that global object is typically the window. In Node, it is the standard object called global. So with this, hopefully you understood two things. When you use the term this inside a function, it references the runtime context for that function. If that function exists within an object, then that runtime context for this is really bound to the owner, which is the object itself. If you use it outside of an object, that runtime context is bound to the global scope. So this will return the global object. Hopefully that was useful. I'll see you in the next demo.
Hi there, I'm Christopher Harrison, Senior Program Manager inside of Microsoft Cloud and AI. And what I want to take a look at in this section is the concept of asynchronous programming and promises. Now, when we think about modern applications are frequently going to be utilizing services that are external to our app. Maybe because we're reading from the file system, we're making REST calls, calling out to a database, or maybe we just have a long-running operation. All of these things can take a little while. And the challenge that we have with an operation that takes a long while is the fact that typically we're only going to have access to a single thread. And if that single thread is waiting for something to happen, nothing else is going to be able to take place. And so our application could appear frozen, or we could just simply have performance issues. So what we want to be able to do is to basically say, hey, you know what? This is going to take a little while. Do your thing, and then when it's done, call me back. And in fact, that's actually the way that JavaScript initially handled this, is through the magic of a callback. And it behaves exactly like that something is going to take a little while, and then when it completes, it's going to call me back. And the way that it will call me back is by calling a function that we give it. Now, in my case, I created a named function, but we could also use an anonymous one. We'll see that on the next slide. And you'll notice that in our example here, we're using setTimeout, which is going to set up a delay. And with setTimeout, it's going to go, hey, tell me what you want me to do. Give me the callback when the timeout completes. And the timeout is going to be measured in milliseconds. So this would wait 3 seconds and then call callback, which would then print timeout completed. Now, the challenge with callbacks is it's quite common in an application to need to be able to do multiple things. That maybe I need to make a call to a REST service, and then to a database, and then to another service. And if we're waiting for all of those different things to take place, our code then winds up getting tabbed in with a callback and another callback and another callback. So while this solution works, it's not ideal. This is where promises come into play. Promises are actually a common development pattern, and sort of like the name implies, a promise is going to be, well, a promise. That it's going to promise me that when the code completes, it will then let me know and give me access to whatever the result happened to be, or just give me the opportunity to start now running some additional code. Now, promises are relatively new to JavaScript, but you are going to notice that most recent versions will have a promise object built in that you can take advantage of. Let's take a look at the syntax for a promise here. Now, there's a lot of code on this slide, I know, but let's go ahead and start to break it down. The first thing that I want you to notice is we're going to create a promise object. The way that a promise object is going to work is it's going to accept a callback. It's going to accept a function that is going to have both a resolve and a reject. Now, inside of this function will be whatever logic it is that we want. And our obligation here is to call resolve whenever the operation succeeds, or make sure that something does call resolve, and then reject when the operation fails, or if the operation fails. So in our case, we're going to use setTimeout, and we can actually just pass in resolve there. So when the timeout completes, it will automatically call resolve, automatically indicating that everything has succeeded. How can we then use this? Well, if you take a look down below, we're now going to call that promise timeout. It's going to give us back the promise because that's what we returned back. We'll be able to call then. Then is going to be executed on success or on resolve. So now I can have whatever syntax it is that I might want here. Now, what you're also going to notice is that if we don't need a full promise object, there's actually a little shortcut called promise.resolve, where we could then pass in a value to go, hey, we've completed, and this is now going to be passed on to the next handler. And you'll notice that we can actually string together handlers from then on. So my next handler there is going to be called when the prior then completes, and we'll even be able to access that response. So that response happened to be 42. We're going to be able to access that and print that out. Now, what happens if something fails? What happens if there is a reject? Well, if there is a reject, that's what we have catch for. And so catch will catch that reject. Now, again, I know that there's an awful lot of moving parts that are there on that slide. Let's get in and take a look at the code in action and help bring all of this together so that way you can see how promises work and where you're going to use them inside of JavaScript. Hi there, I'm Christopher Harrison, Senior Program Manager, Microsoft Cloud and AI, and let's take a look at the code at a demo for how we can use promises inside of JavaScript to manage long-running operations. Now, the way that we're going to do this is the same way that we did it in the slides, which is we're going to take what was built for callbacks and convert that into something that could be used with promises. So, inside of JavaScript, we've had for a very long time this little thing called setTimeout, which will take a callback that it's going to call once it's done running. Well, we want to do that with a promise. So I'm going to say function, and I'm going to call this promise timeout, and we'll ask for the milliseconds, and then we'll go ahead and say return new promise. So remember, of course, that when we're talking about our promises, it's all based around this promise object. Now, the promise object, the constructor here, what it is that we're going to use to create this, is going to be looking for the logic. It's going to ask us to put whatever it is that we want to have happen right inside of that function there. And we'll do this by setting up an anonymous function. Now, the promise will go ahead and call this, and it will give us two little parameters that will allow us to indicate success or failure. Resolve is going to be called to indicate success, and reject is called to indicate failure. So once we know that things succeed, we could just go ahead and say resolve, and if we wanted to pass in a value, we could go ahead and do that, and voila, the promise has now succeeded. Reject would simply indicate that it failed. Now, because of the fact that resolve and reject are nothing more than functions, we can use that inside of setTimeout. So I'm going to say setTimeout and call resolve. So that's going to resolve or complete, if you will, the promise once the timer has elapsed. And the timer is going to be set to the number of milliseconds that were passed in. So now I can use this. Now I can go ahead and say promise timeout, specify a value, let's say 2000, then, and our then is going to be on success. So when things succeed, we'll go ahead and say console log and done. And should things fail, then we can have our catch. And our catch will then have a very complex set of error handling. Console log error. Okay, in your real applications, you probably want something more than that. All right, let me go ahead and save that. And now I'm going to go ahead and say node and promise demo. Cool. And when I run this, 2 seconds will go by, and we'll get done. Now, just to highlight the fact that our reject is going to raise an error, and that would wind up inside of catch, let me change my code here to call reject, and now after that 2-second delay, you're going to notice that it gives us that error. All right. Now, one other thing that's worth highlighting here is the fact that we could go ahead and continue to string these together. Let me make sure I change that back to resolve here. So I could, right here, go ahead and close that off, .then, and let's set up another one right here. A little bit of cleanup, perfect. Okay, and then console, console log. Also done. Cool. And so now I could go ahead and say return, and let's say promise timeout, and then say 1000. And so now what's going to happen is this first spot's going to run, and then the second, and that will then execute, or the response to it will then execute on the next then. And this is something that you're going to see quite commonly in code, because quite frequently what you'll do is you'll make a call out to one service, get a response, have to do something with it, and then maybe, call back to save the value, or maybe call out to another service. So it's quite common to go then the whole way down. Now, I also want to highlight the fact that, and let me just do a real quick copy and paste here, that we could pass values down or, resolve a promise by using a little helper here. So I'm going to say resolve 42. And now I'll put in my result here. And now we'll go ahead and say console log and then the result. So that result will be whatever is inside of the resolve. So now when I run this, what we're going to notice is we're going to see done, also done, and then that number 42. And so that is how we can utilize promises in code to manage our long-running asynchronous operations. Hi there, I'm Christopher Harrison, Senior Program Manager inside of Microsoft Cloud and AI, and let's take a look at this relatively new, at least to JavaScript, concept called async await. Now, what async await is going to do for us is it's going to help make asynchronous code look synchronous. That while promises are cleaner, they're not necessarily perfect, that they can still add a little bit of bloat to our code, and they require like a little bit of a different paradigm. They wind up thinking, they wind up causing you to think about how it is that you're going to write your code in a relatively different fashion. Because after all, you're still kind of using callbacks, just with a different syntax. This is where async await comes into play. Now, async await is going to allow us to make asynchronous code look a little bit more synchronous. And you're also going to notice that async await is rather common in a lot of other programming languages as well. So let's take a look at our async await syntax, and then we're going to get in and take a look at our demo. Now, you're going to notice up at the top that I've got that promise timeout, returning our new promise, and everything that we had from before. So if you've already watched our section on promises, which if you haven't, you should definitely go take a look at it, then what you'll notice is the fact that we've already seen that syntax. Now, what we're going to do here that's going to be different is we're going to take advantage of async await. And this will actually work with anything that's going to return a promise. We start off our async await by utilizing async. You use async when you're declaring a function to indicate the fact that it's going to have an await call inside of it. Now, the rest of my function can do whatever it is that it might want, and then eventually here, we're going to have an await. Now, you'll notice that I put into quotes here that it pauses while the operation completes. It pauses our code execution. Now, what's actually happening here is it's going to go ahead, make the call, wait for a promise here, and then once it finishes, it's going to evaluate and then run the next line of code. But keep in mind that other things could still happen, that this is still our indication that, hey, this is going to take a minute. So the thread could be then used for other operations. So while it looks synchronous, it's actually still going to be asynchronous. You'll notice that I'm going to return back the number 42 here. And what's going to happen is this will actually be wrapped inside of a promise automatically for us. So it's basically the same as us calling that promise.resolve, that it will automatically be wrapped up. Why is this important? Well, it's important because now I can use this function like any other function that returns back a promise. So I can await that function as well. So I can then go ahead, call that simulate long operation, and get the value back. Now, because of the fact that it's going to give me a value, what you'll notice is I'm going to go ahead and say const whatever my value is equals await, and then the function call. So it will give me back, in this case, that number 42. We'll be able to then print it out. Now, the way that I then execute all of my code is by calling that run command that you see down at the very bottom. If there are any error messages, I'm going to grab those by utilizing try catch, which, by the way, is another great advantage to utilizing async await, because it allows me to now use syntax that I'm already familiar with. Let's see async await in example form, in demo form. Hi there, Christopher Harrison, Senior Program Manager, Microsoft. Let's take a look at how we can utilize async await to manage our asynchronous calls inside of JavaScript. Now, one big thing to keep in mind about async await is the fact that these are, or this is, built on top of promises. And so as a result, we're going to start with the little helper function that we had from before, that promise timeout, that converts a promise into async await, which, by the way, means that any time at all that you're calling a function that's going to give you back a promise, you can use the async await syntax. Now, async await starts with an asynchronous function. So I'm going to say async function, and we'll give this name of run in my case. And then now I'm going to go ahead and put in my, my logic here. Now, one big thing to keep in mind about the way that JavaScript works is I'm not able to use await unless I'm inside of an asynchronous function. As such, what I need to do is I need to create that function and then go ahead and call it there. That I'm not allowed to just simply say await and then promise timeout. That, unfortunately, that syntax is not going to work here. All right. Now, the way that await is going to work is it's going to logically block execution, if you will, but still actually allow the thread to be used by something else behind the scenes. So while our code running, if you will, is going to look like it's stopping, behind the scenes, it's actually still able to do other things if that's what needs to happen. So I'm going to say await, and then let's say promise timeout, and let's say 1,000. Actually, I'm going to do 2,000. There we go. And I'm going to just say right up here, console log, start, and then console.log, and then stop. Okay, cool. So now when I run this, what's going to happen is it's going to print out that start, the pause, and then stop. So even though it looks like all three of these lines of code are just boom, 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 you're going to notice that it's going to pause and wait for the execution to take place. Again, it's just pausing here. Behind the scenes, other things could potentially be happening. Now, one of the big things about JavaScript, and there are certain tools that can help you catch things like this, is it's possible for me to call a function that's going to return a promise without putting in an await. And when I do that, you notice that I get different behavior here. Let me go ahead and just add in a real quick console.log. No, that's not really going to behave the way that I want it to. That's all right. So let me rerun this, and let's sort of keep an eye on what's happening. That what you're going to notice is I've got my start here, I've got my stop there. Now, when I had the await right there, let me make sure I save this, and I ran this, you'll notice start and then stop. Without this await, what you're going to notice, big change here, is the fact that it's going to go start, stop, then the pause afterwards. And the reason is because I didn't pause the execution, if you will. I did not put in that await right here, which is going to be required. So if you're ever getting unusual behavior, or you're getting error messages about an expected return value not being what you expected it to be, quite frequently it's because you missed an await. So keep that in mind. Whenever you're working with promises, always, always, always make sure, if you're using async await, to use that await. And so as another example here, let me go ahead and say async function long running operation. So let's just pretend, if you will, that was going to go call a server or do something long running. So it would, my logic here. In our case, I'm just simply going to say return and then 42. Now I can go grab that value by saying const response equals await and then that long running operation. And then if I say console log and then the response, what you'll notice is that it's going to print out the number 42. And the reason for that is because it's going to go run that, wait for the promise to complete, which will have happened instantaneously because we just returned the number 42, and then give me access to that value. If we don't do that, if we don't have that await, note the difference here. Note the difference in the output. Let me just put in a couple of returns here. So if I rerun this, now what you're going to notice down here is that I'm going to get start. Oops, let's make sure I save this. There we go. Try this one more time. Okay. So let me run this one more time. Start. And then you'll notice that it's going to give me back this promise 42. And the reason that it's doing that is because I don't have that await. The reason that it worked that first time was just because I hadn't saved the file, so the await was still there. So if you're ever seeing that behavior, it's going to be because you forgot to put in await. Now, what I really like about using async await is that this feels more natural to me than using then for managing our promises. And you're also going to notice that really going forward, this is going to continue to become more common, not only just inside of JavaScript, but also in other programming languages. And so that is how we can utilize async await for managing promises inside of JavaScript.
Hi everyone, my name is Johan and I'm a senior cloud developer advocate working at Microsoft. In this video, we'll talk about packages, what they are, why they are important, and how to use them. But first, what's a package? A package is a reusable bundle of code that may also include other things like images, fonts, or any resources. Packages can be many things, like libraries that you use to build your applications. For example, React, Angular, or Express. They can also be tools like the TypeScript compiler, unit test runner, or code formatters. You'll probably use a lot of third-party packages to build your application. And at some point, you may even create your own private packages to share some components if you have multiple applications. Ultimately, even the application you're creating is a package. You may also hear sometimes the words dependencies or modules when going through documentation. It may be confusing at first, but it's only different words for meaning packages at the end. You might wonder now, where can I find packages to use in my project? In the JavaScript ecosystem, there's multiple places where you can find packages, but the most popular one is NPM. There's more than 1 million packages on NPM, and that number is growing every day. It's both a registry, meaning a place where you can share and download packages from, and also a CLI tool. The NPM CLI comes with every Node.js installation, and that's what we'll use to manage packages in our project. Now, why are packages important? If you look at this code here, this is a full functional web server, built with less than 10 lines of JavaScript. Think about it for a second. If we did not use a package here, we would have to write way more code than that, to handle the routing of the HTTP request, to create the HTTP response, to handle the formatting of the headers, the transformation of the data, and a lot of other complex and boring tasks. Thanks to the Express package and this single line of code we have here at the beginning, you don't have to code all of that. You can focus on what really matters and be way more productive. To be able to use packages in your application, it all starts with a file named package.json. This is a JSON file that consists of mainly 3 groups of information. You'll find in there a lot of metadata, like your project's name, version, license, and some other information. Then you'll find a dependencies section. This is the list of the packages that you use in your project. Said otherwise, this is the packages your project depends on. And finally, you have a script section. This is where you can put commands to automate your development tasks, like, for example, compiling your code or running your tests. To create this file, you can use the npm CLI init command. It will ask you a bunch of questions and it will create the package.json file for you. If you want to start quickly, you can even skip the prompts and fill in the fields later using the -y option. Once you have the package.json file, you can start installing packages. For that, you have to use the command npm install, followed by the name of the package you want to install. If you add the option --dev to this command, the package will be added to a different section of your package.json file called dev dependencies instead of dependencies. But what's the difference between the two? In your project, you'll find 2 kinds of packages. There will be packages that your application needs in order to be able to run in production. These packages will be your dependencies. There are also packages that you need during the development of your app to help you, like test libraries, code formatters, or compiler tools. But these are only useful during development. You don't want to ship their code in production, because it's useless. As these packages are only needed for development, that's why they are called dev dependencies. In the next video, let's put all of that in practice and create a new project that uses packages. Hi everyone, my name is Johan and I'm a senior cloud developer advocate working at Microsoft. In this video, we'll see how to install and use packages in a JavaScript application. To be able to use packages in my application, I will have to create this file named package.json. To do that, I can use the npm CLI by typing npm init. And because I'm lazy, I don't want to answer a few prompts, so I will use this -y option. It will create for me this package.json file. As you can see, there's a few informations in there, like name and version of my application. But you don't see a dependencies section. That's because we didn't have at this point install any package. So let's just do that. I will install a package I only need for development, so I will use the -- save dev option. I will install Prettier, which is a code formatter. Okay, now you can see that there's this new dev dependencies section with the package I just installed in there. To make use of that package, I can add a script. I will name this script format. And I will make use of this Prettier package to make it reformat all my JavaScript code. Now that I created this format script, I can run it using npm run format, and that will just run the command I just written in there. To see it in action, let's just see this badly formatted code I've just written. So if I run this command, you can see that now I have a pretty clean code. As you can see here, I'm trying to use the Express package, but I don't have it yet in my application, so let's install it. To do that, I type npm install express. Now I'll have this dependencies section with Express in there. Express is a package that allows me to create web server and web APIs. The code I've written here is a simple web server that will listen up for 3000 and will answer a hello world to a request. To run it, I can use node index.js. And you'll see that my server is running. To make it more convenient, I can also add a new script named start here. And I can type just the same command as used in the terminal. Now, instead of typing node index.js, I can just type npm start. Start is a special script, that's why I don't have to use the full command name npm run start. I can use this shortcut one just called npm start. Also, maybe you have already noticed it, but in VS Code I have this npm script section in there. You can use this section to do exactly the same thing I just did in the terminal and execute my script. Now let's add a new package to my application called .env. I will do that by typing the npm install .env command. And now you can see it in my dependencies here. .env is a package that allows you to manage your application configuration, including the secrets. For example, if I open my source code here, you can see that the port of my server is 3000, but it's hard-coded in my code, meaning if I want to change it in production, I can't. And it also means that it's hard-coded and everyone can see it if I push my code to a repository. This is something that may be fine for configuration setting like here the application port. But if you have secrets like for example the credential to access your database, you really don't want that to appear in your code. To avoid that, you can replace these hard-coded values in your code by using environment variables. To do that, I can replace this hard-coded value here with process.env.port. Port will be the name of my environment variable. But how to set this value here? Because just like that, it doesn't have any value. That's where the .env package becomes useful. To make this magic work, just at the beginning, I will call it. So let's require .env and call the config method. This will do all the magic. Adding this line here will allow me to create a new file named .env, hence the package name. In this file, I can just put all my configuration for my application. For example, I can set the port to be this time the value 5000. What the package will do is at runtime read this file and just map all the settings in there to environment variables. If I try to run my application again, you will see now that my server is listening on port 5000. But wait, what I just did is put all my configuration in a different file, But if I just keep it like this, it might still end up in your repository. What you need to do now is make sure that this .on file will never be committed into your Git repository. To do that, I will create a new gitignore file, and I will put in there the .on file, but also this folder that you can just see here, the node modules folder. This node modules folder here is where all the dependencies that you added to your project will be downloaded. So that's not something you want to commit to your Git repository. That's it. Now you can be sure that your secrets are safe and that you can use different settings for your application configuration in production.
To the end of this series and actually watched all of the videos, well, first of all, thank you. And then second of all, I hope that you picked up quite a bit about JavaScript and you feel ready to take that next step. Now, if you take a look at the links below, or you take a look inside of the GitHub repository, you'll notice that we've provided a bunch of next steps that you can work through to start to take your development skills up to the next level. The main focus from here is to get in and start doing something with it. That knowledge is just like any other muscle. If you don't use it, it will atrophy. And you want to make sure that you use it as quickly as possible. So from the moment that you've learned it, that's when you want to get in and start using it. So the call to action here, the great next step is to start using it. So we've provided you some links to some various quick starts and to some neat little SDKs that you can go in and start playing around with. And then that way you can start to create some of your own apps. So thanks again for checking all of this out. And again, go write some code.